Good morning, everyone. I hope you're all doing well today. Let me just bring up the live stream. Just make sure we're live. Okay, dokie. Great, fantastic. Let me just share this with everyone in our community. As it suggests, we are studying maths today because I have forgotten some of it. And it's important to know maths, right, when it comes to game dev. But this is game dev maths. It is very, yes, this maths is very, very selective in the sense that I'll be studying stuff that's only used for game devs, really. I would be studying pure maths theory. I just kind of want a more of a chilled out session today. I'll get into it why in a minute. So I'm going to take a little break from game dev just to do a bit of studying. The chat is there, available. Okay, so yes, just so people who are aware, what did we do last time? Because I don't think it's been a while. I might as well show you guys what I've been doing. What ended up happening in the last live stream anyway. So we started on building up imposters or billboards. I should say billboards. Imposters is a use of billboards for our... Hello. Yeah, who's this? I know, yeah. Hi, Ratchet. How you doing? Yeah, making this game engine. Thanks for asking, by the way, Brown Bean. Good to see you. Yes, I'll just explain. So I've been making this game engine in C++ and Vulkan. I'm going to make a little space game. And we were trying to build billboards, which are just a way of implementing... what are they called? Like... what are they called? Sprites that always face the camera. So if I were to run the game, and you would see my terrible UI. Ta-da! Terrible UI, right? This is just a 2D renderer I built in the last couple of streams, and it's a sprite-based 2D renderer. If I press start, it loads the game, and this is the player, right? So we started to work on, if I turn off the debug geometry, we started to work on billboards. We didn't get very far because it was in the last like 10 minutes of the live stream. So yeah, obviously you can crash into rocks and delete them. That'll be a stand-in for bullets. You will be able to fire bullets at some point that crash into asteroids that break. This is just a... I'll remove the fact that the player is crashing into them. And obviously you won't be a duck flying around, Brown Bean. So that will be eventually a video game that you can actually play. This stream just randomly popped up in my feed. Cool. Thank you for joining us. I hope you have a good time. So what we're going to be doing today is a little different than just straight development. I feel like I've been doing so much development recently. It's been a bit overwhelming, and I will explain a little bit why. So I have this book called... Foundations of Game Engine Development, Volume 1 Maths, or Mathematics. It's a fantastic book. It's pure game dev math. So if I open it up in like this, you can see that some of the stuff we'll be studying is in the sample chapter. And yes, literally we'll go actually we're going to go exactly over this. I do recommend this if you're really serious about game engine development. It's a book I've personally read from cover to cover, but I've forgotten some of it because the volume 2 one down here builds off volume 1 and some of the maths in the geometry section. For example, how it describes planes and rays and lines are not typical. You don't really find this type of syntax. I wonder if it's in the sample chapter. But either way, we're going to be studying it. This book is not free. I will be reading from a scanned PDF version. But if you want to, if you are, like I said, serious in getting this, I would highly recommend. I've left a link to this website in the description of the video, of the live stream even. And I do recommend picking this up if you are interested in diving into more advanced maths, for example. This is for game dev anyway. Like, for example, it goes into geometric algebra, which is actually like really cool stuff. It like unifies all the linear algebra that you learn across, regular linear algebra, and kind of brings it all together into this like unified system, which makes things like easier to calculate. Typically with the wedge product, it says Grashman algebra, but it generally is now called geometric algebra, which is different from. It's such a bad name, to be honest. Considering it's like, well, isn't this the same as working out the area of a circle? That's geometric algebra, right? You do algebra to do some geometry, and I think everyone can probably already do that, like work out a the area of a circle. It's not exactly too difficult, but no, this is linear algebra plus geometry, if you can think of it like that. So vectors and matrices plus geometry. Hello, Kalia. So before we get started, though, I want to talk a little bit about what people asked for in the last live stream, which was to build a roadmap. And I really struggled with this, actually. I actually started writing a script. I was going to make a video about it, but I think it ballooned up immediately into a very difficult topic to talk about, because the stuff I was asking people to do was going to take years, in my opinion. I'm pretty sure the area of a circle is radius times radius. Exactly. And yes, I threw a quick roadmap up together on the Discord, but the problem is with a real roadmap, which is outside of just learning Vulkan or whatever. Oh, I've got this looping. I can probably put up with not looping. The problem is with just like a roadmap. It's like, how do you learn everything that's necessary to build a game engine? That is hard to like quantify, because it takes a lot of practice, and it doesn't just take practice in learning Vulkan, which people were asking about, like, how do you learn Vulkan? How do you learn Vulkan? And I also, this is the other side of things, I don't feel qualified really to give you a proper roadmap, considering my lack of success. But I want to talk about a little bit just at the beginning of this live stream, to talk about like what it means to make a game engine at the level of what people typically are describing. Most people aren't talking about if I was to plug in my old hard drive and give me a minute and load up my like early games, right? So I'll let that music play a little bit longer and it'll move on to something else. But if I just let this load for a minute, and I'll talk about like some of my earlier games once it's mounted, which is good. So if I was to go into my old games and play, okay, so some of this is like super loud, so I'm just gonna like kind of mute the audio for just a minute, because it's like, or just make it really quiet because the music is terrible. Like, people aren't talking about making this, for example. This is a game engine, right? It's a Pong game engine I made from a YouTube series back in 2012, right? This is not what people are talking about. They're talking about like making a 3D game engine, and how to do like nice graphics and have like interesting gameplay. That requires a lot more effort, right? A game engine can actually be simpler than using a game engine. Let's just turn up the music again. So the problem is with saying like, oh, if you want to make a 3D game engine that's going to have a 3D game that's going to play, that's going to do this and that, that is going to take so much more than just what this is, right? This is like, I remember this being 900 lines of code to build that Pong game from scratch with the SDL 1.2 renderer in 2012. As you can see, some of these are 2012. Okay, 2013 perhaps, yes. So this is like a long time ago. So it's like, what it takes is practice and years of it, in my opinion, unless you're extremely talented, which I'm not. So it takes like knowing C++ really well. It takes like knowing some maths really well. It takes some knowing graphics theory really well. It takes knowing Vulkan really well. It takes like applications of all those things combined to make a good piece of software. So it knows you need to like good software engineering, like, well, it's not just like knowing design patterns. It's like, how do you integrate, how do you transform data efficiently? Threading, maybe it requires SIMD knowledge. Maybe you have to know a bit of assembly. it just goes, and it like project management. Maybe you have to build a learn some CMake so it's cross-platform. You know, you have to learn debugging skills, like how to debug stuff, like how the computer works, the hardware requirements that you're actually aiming for, and how to target these particular pieces of hardware. And it just takes iteration over iteration over iteration of getting better and better and better, and that takes time. And for me, it was like it was overwhelming to try and like come up with any like structured path that would be like remotely useful for anyone that wasn't just going to take a multi-year long learning path to learn this stuff. And I think it generally, because it's generally one of the harder things to do in game development, in programming, and to ask people to do like even the bare minimum. I think I had a list. I don't know if it's on this computer, but like when I was talking about like learning C++, I don't know if I was writing a script on this or the other computer. If it isn't, oh, okay, I did, thank you. So, like, I had this list of, like, before moving on to learn Vulkan, this is, like, what you should know. You should know all the basic types. This is in C++. All control flows, all the loops, all the data structures, which includes the standard vector, stack, and map at the very least. Dynamic memory, how to use it. Pointers, references, double pointers, and reference to pointers, all casting types. All static and dynamic arrays, maps, and how they work in general. Queues and maps, they're very important for game dev. Class structures and functions, basics, arguments, pass by value, reference, pointer, pros and cons of these. Preprocessor, how that works. Learn the three different uses of static, global, state, and general. Learn what inline does. Learn the singleton pattern at the very least. Learn inheritance, polymorphism, composition, and object-oriented programming. The is and has relationship basics. Learn how to debug your program. At least learn one debugger. Learn what runtime issues you can run into, like accessing a null pointer, dereferencing a null pointer, read access violations, write access violations, for example. Basic consness, like const functions, const pointers, const reference, const values, const expr. Basic exception handling, assert and static runtime asserts. Learn C++, like different C++ compilers. That's like, you can learn that in like 2 seconds. Basic templates, nothing crazy. Just know how to understand, like write a class base and a function based template. Lambdas. Learn what libraries are and the difference between static and dynamic. Learn what the size of operator is extremely important. Learn what overloading operators are. Learn how the destructors and constructors work. Learn scopes, so file function scopes, global scopes, all that kind of stuff. Learn how to do file I/O, and that was just like, learn all this before you learn anything Vulkan. And I still think that there's probably more to this list that I haven't actually thought of. And I was just thinking, like, bro, this is just like, this took me forever to learn this stuff. This would be like going through the entire learncpp.com, and I was like listing the books that I've read. I hadn't actually finished listing them, but I've read through multiple C++ books. And I was like, bro, this is insane. Like, what am I? This is like learning C++ well enough that you can develop a game engine already is like setting the bar extremely high for like someone who's never programmed at all. And it just became like this massive, like, difficult task. And like I said, I don't even know if I've got everything here that you would actually like need to be competent enough that you wouldn't completely fall apart. And this is the minimum. This is the minimum. Like, that I was suggesting. Like, this is like the basics, right? Like, there's so much more in C++ that would and general software engineering that would be required to continue. And I just kind of not burnt out, but I kind of got worried that it would be too much and it would require so much work that I was like, you know what? If you actually want to learn this stuff, like, put yourself through the game engine architecture. Oops, I keep saying text with C when I type this out for some reason. Game engine architecture book, right? This, it's not docs myself. Yeah, because unfortunately I don't know if I caught it in time, but it is what it is if it isn't. Anyway, this thing, right? This book will go through the basics with like in general what you need to know for most game engine developments. And this is a big, massive book. So it's like, yeah, this is what a junior should know, you know. And this book will take you if you take it seriously and you go through it, it's going to take you a long time. And even then, you won't know any graphics. You'll know like basic graphics, like some graphics theory, but you won't know any Vulkan. It doesn't teach you Vulkan. It just teaches you all the tools that you'll need. Not necessarily like everything for indie game engine development. It's not quite the same. But if you want to make a serious attempt at game engine development, then this is going to be a massive like a big task, like undertaking task. So let me just read some of the chat because I just wanted to get that off my chest. Like it's I just needed to like get that out there. So it's a tough one to, you know, tell people to do so much while I also haven't succeeded, by the way. This is, you know, like I don't have any. I've worked as a C++ programmer for like 6 years and 11 months. I don't have a game on Steam that I can point to and say, look, this is success. This is what success looks like. All I can say is like what to reach. This is how you reach my level, which may be bad. I don't even know, right? I've completely lost how good I am. I don't know how good I am relative to other people. I don't know. I really have no idea. So, you know, it's it's a tough one. Anyway, so I'll just read the chat while we're talking about this. So, I'm still learning C++. Oh man, it's big. Yes, a 3D game expects immense knowledge, at least 5 to 10 years. I can say that, yes, 100%. I'm at constructors and destructors. Ah, fantastic. Hello. I'm not a big fan of singletons personally. They're just obfuscation of globals. Yes, that's the thing, right? I think Ratchet knows he's not a big fan of singletons, but he knows what it is, right? It's important to know these things, right? That's the thing. It's like, if you don't know what a singleton is, I'm not saying that you should use them, but I think it's like probably my favorite pattern, which we can disagree on that. The reason I use it is for making sure things are initialized. That's all it is, right? But like Ratchet knows like how the processor initializes memory, so he doesn't have to worry about singletons as much, because he can understand that there's an initialization part, there's an uninitialized part of memory that exists when the program becomes a processor, right? A process that runs. So it's like there's so much behind just the fact that you can have a good opinion or a bad opinion about like singletons and stuff like that requires a lot of knowledge like already baked into that, which is kind of hard to like just. It's kind of hard to build a roadmap to get to that point where you can make a decision not to use singletons from someone who knows nothing, right? I mean, after the basics, you just have to search and learn your way. Yeah, basically, it's like, I feel overwhelmed with it. Same. I feel overwhelmed too, dude. Over 1,000 pages. Yeah, 1,300 pages. 4th edition is really good. The best one so far. Yeah, I would recommend. How do you understand each formula? Each formula, so mathematically speaking, make sure if you're talking about like maths, like how to understand game dev maths, I would recommend, depending on what your level is, just starting out with something like nice. There is a great video by One Lone Coder about like game dev maths. So if I bring up game dev maths, right? So One Lone Coder, I think he has like game dev maths or something. I don't think that's what it's called. This one, right? I would recommend just going through this. This is it's not going to teach you literally everything you need, but it's going to give you like, it's going to make you have to learn the absolute basics. So he talks about the Pythagoras theorem, which you hopefully should know, but like how that relates to games. Then he talks about trigonometry and how that relates to games. Then he talks about vectors and like how that relates to games, which is basically building off the Pythagoras theorem, and linear interpolation, which is extremely useful. And yeah, then he applies it in like a basic idea of like how motion works. This should be like what I would call like the gate towards learning all the maths, right? If you don't know any of this stuff, like you're gonna struggle picking up a book even on game dev maths. because this book, like the one I'm about to like kind of rattle on for a couple of hours, like this book here, like let me just go through the table of contents. Like it talks about vector basics, but then it like immediately moves past it and assumes that you kind of already know the stuff. And yes, it's a whole chapter on the basics, but it's going to be like quite brief. And it assumes that you can just be like, oh yeah, I know what the dot product is, but I don't quite know exactly how to do like specific things with dot products. Like it assumes you know something about the dot product, otherwise it would, because it kind of just goes, here's a dot product, here's what it does, and here's the application of the cosine law with the dot products kind of thing, right? It's like it just like builds on quite quickly. So I would say definitely start with this, and with maths, just to finish off with the maths. Like it's a topic that builds on itself. So if you're missing some understanding, you're gonna have to take a step back and kind of build up from there. So hopefully that helps you understand. I feel the same way of not being good enough. Every version of C++ is literally in new code. I feel you on that one. Yeah, it's tough. It's that's why I went with that's why I've personally gone, with like a simpler C++ that kind of all compilers support. There's no, advanced C++ in here. I just follow Strup's Strup's book, and do not get stressed. That's good. That's good. Singletons make it a bit hard to reason about data access, which makes writing multi-threaded code harder. Well, in general, globals in general. Yes, I would say globals in general. I think it's with, okay, so I'm not going to go too much into that, like singletons versus non-singletons, but I will just say that you can just run the instance like at a particular point in my program and just make sure that the constructor has ran at a particular point, rather than, I don't know what you would do differently, honestly, like what your pattern is or non-pattern. But yeah, that's what I'm doing anyway. So I can just like set up the, like if I go into main, like I set up a bunch of like global state like instantly, and then I can do that before any threading happens. So it's like I know that I at least have, like, for example, my basic allocators, not thread safe allocators admittedly, but I have my basic allocators set up before I even do the window, and I definitely have the window initialized because I again use another singleton here. It's not the only way of doing it, definitely. But yeah, that's my reasoning at least. But I think again, to have that ability to reason about why you want to do something, it takes like time and practice, and it's been tough to come up with like a coherent plan for anyone to follow. That's like not, oh yeah, just spend 5 years doing anything, just doing this. And this was like, I expected this part of the video I was going to make. I don't know if I'll make it, to be honest. To be like, oh yeah, this is just like a footnote. This was like supposed to be like 2 paragraphs at most, and it kind of just kept going. And I only recommended two resources at that point, so I was kind of like, oh god, this is gonna this is gonna go on and on and on. So yeah, it's that. So we're gonna make a so I'm just gonna scroll down to my my geometry book. But yeah, please support the author. This is not a free book. If you can afford it, if you do want to learn this stuff, it is very good in my opinion. But I don't think, I was always thinking about this before the stream, I don't think me reading parts of the book are going to be a substitute for buying the book itself. Especially because I'm going to start at chapter 3 and kind of bounce around to bits. Because I just want to take like a bit of a break from deving for a bit. I just want to do a bit of a maths, which I feel like I've got weaker in, because I haven't kept up with it or taken notes. I didn't take notes at this point in time. So yeah, we're gonna make some notes. Yeah, that's what I was talking about with the initialized and non-initialized space, by the way. Like understanding this, like the general like processor, what a process in memory looks like, this type of thing. That I think Ratchet in the chat understands quite well, because he can understand like how global data is initialized in BSS space and initialized space. So yeah, it's like I'm putting it on the stack, right, versus using these two. But like again, if people don't know what the stack or the heap is, then I've got to be like, all right, learn the stack or the heap first. That's kind of more important than just like trying to understand everything all at once, because that's gonna be more relevant. So like, you know what I mean? Like when I was trying to make this roadmap, it was a bit of a like there was so many like other things that you had to like know before like I continued to even let you and even then you can learn a lot of this just on the fly. Like that was the other thing as well. Like you can learn what the stack of the heap is like halfway through making your Vulkan renderer. So there was that as well. There was like a lot of that kind of stuff going on. But anyway, hello. Thank you for joining us, by the way, guys. I very much appreciate you all joining in. Hello, guys. Welcome back. It's not about initialization. That's the issue. It's when a singleton can mutate. Multiple threads can. Oh, I see. You're talking about. Okay. So that makes sense. Okay. So yes, that makes sense. That yes, you would have to make it thread safe if the singletons were writing to memory. I see. Heap is basically for free storage in computer memory. Yeah, I didn't quite understand what you meant there, Ratchet, but thanks for clarifying. But again, you know that your knowledge there, like you know a lot more about memory. That's not even graphics related. Like you're talking about like shared memory, synchronization issues. You know, like reading or writing from something. You know, like there's a lot more you would need to know to kind of like build a like multi-threaded game engine, right? Heap is so it's also called dynamic memory. Sure. So yeah, it's saw your post on the roadmap. Very nice conclusion, if I do say so. Thank you. Thank you. I was a bit nervous about that, but I really, it's just practice. Honestly, it just takes practice, and there's no real shortcut. But like I think you already read that, so yeah. Basically, Kalia, you're basically right there. It's just when people say like heap and dynamic memory, that can go a lot deeper than just using the new operator in C++, right? That can be like you now know how the operating system like does paging and like how pages interact with each other, like how to allocate efficiently with moving memory without fragmenting memory, like what a memory pool is. It's like I'm not trying to bombard you with like concepts, right? But I'm saying that dynamic memory in itself like has a lot more to it, which may affect your game engine. And it's like I don't know what I should tell people to learn and what's good, what's relevant, what isn't relevant, because I use a lot of like knowledge of like how the heap functions, I guess. Like I use a memory pool. I try to avoid fragmentation. I use like different allocators to, basically use a stack instead of but on the heap. You know, like there's like a couple of things that I'm doing here to speed up allocation. For example, like pulling vertices off a GLTF model. Like I'm using the stack, but like I'm using a memory pool, which is the heap technically, but it's like I'm rewriting that piece of memory over and over again to the same parts after I've used it, so it's like faster. So that's like it's things like that. Like how do I get people to like understand the whole computer science world plus graphics on top of that? It's just kind of tough. And then again, like finally, I'll just end on this. I don't know. I feel like I don't know enough personally, and I don't think I'm that successful at this. There are people in our Discord and in our community that are better than me at game engine development. Like I've seen, like I think I've talked about this before, but I've seen other people's game engines, and what I would see, like just based on like what I've seen, they're generally like bigger and I've got a more intricate and I think more stable than my game engine is, right? So it's like that's why I don't feel like super confident in like giving like people the roadmap, the the road, this is how you get good at this, when there are so many people in our community. Not so many. Our community is still quite small. There are people in our community, I'll just say, that will probably be more qualified to give advice on like how to climb the ladder of competence. So yeah, that was like that's why I kind of just threw together a quick roadmap on the Discord server, which I think is still valid, but it's hopefully you can appreciate how difficult it is to kind of make a good roadmap without saying, oh yeah, just spend 3 to 5 years doing this and then you'll eventually know what to do. So yeah, you won't need a roadmap after 3 years of study or 5 years of study because you'll be competent enough to know what to do. I just think that was like kind of tough. Unless you're super talented, perhaps you could probably blast through this so quick that no one would you wouldn't need some guy on the internet to tell you what the roadmap is. But yeah, feel free to ask questions, by the way, about like how to learn this stuff. Like I think it's more useful, I think, if people are interested in learning this stuff, that they just ask questions when they get to a particular point. Like how do I learn Vulkan, for example, is a good question to ask when you've already started to try and learn Vulkan. It's like, I don't understand descriptor sets, or I don't understand synchronization. Then it's like easier to recommend a resource or something like that, right? Rather than like, how do I learn Vulkan? Give me everything all at once. Because, I don't know how much you already know. I don't know how familiar you are with computer science stuff and programming in general. So it's like it'll be nicer for me, I think, and probably more beneficial. I might still make the video. I'm not gonna say I'm not gonna make the video, but if I do make the video, it might be like 50 minutes long, and it might encapsulate a lot of different things. It might take a while to come out as well. So I thought, it's a tough one. So if it does come out, I'll just say like it's gonna be a long path, but we're on it together, so hopefully that's helps that we're all just read the fucking specification. Solid foundation, allocators, new operator. Yeah, that's like part of the heap and stuff. Yeah, but to be honest, that's just what I end up doing these days. Yeah, I mean, Ratchet's right there, by the way. It's although we're joking, I've read some of the spec, and even the little bits I've read, it's like, oh, okay, this is how this works, because the drivers have to implement the spec as written, with all its is, has, and must language that it uses. I've forgotten it uses very specific language, so graphics driver vendors can actually absolutely stick to it. Anyway, so what are we doing today then? To take a chill. After that, to rant. Hopefully you enjoyed that rant. I feel like it wasn't just like me, just old man goes crazy on the internet type thing. So yeah, I will. So I've forgotten some maths, so let's just go through maths. We're going to be doing geometry. I don't know how long we're going to do it for. I still need to get things working on Linux. I haven't done that yet. So maybe there'll be a Linux stream one day, but I don't know. Development, maths. Yeah, so again, if you do want to learn this stuff and you are serious, like, start with something a little bit simpler than what I'm about to show, but if you do want to dive into it properly, this is a good book for that. Okay, that's it. That's all I'll say on that. I've left it, like I said, I've left a link in the live stream for this book. Again, it's not free, but it's not that expensive either. Honestly, it's quite short. It's like 100 and it's not that many pages. It's actually quite a short book. If I was to actually look it up, I'm gonna go on private browser because honestly, I gotta be careful with Amazon. It like doxes my location. What is it called? Amazon, that's the one. Nope. Foundations of game engine development. So, yeah, if you get this, how many pages is it? Decline, and it's quite short. Where is it? It's gone up in price since I last used it. So it's pages. Where's the pages, bro? 200 pages, right? It's not that long. It's still, obviously it's quite long, but even if it's 2016, it's not going to go out of date really. It doesn't really matter, right? It's like 2016. Yeah, maths is still kind of the same. It's not like we've discovered new maths that makes it obsolete, or implemented new math software that kind of replaces it. But anyway, yeah, check it out. It's good reference. And also the 0 to Geo series, if you want to take that to the next, like after you've read that book, a good complement with that would be, sorry, I haven't finished yet, but 0 to Geo. This playlist is very good. This is Geometric Algebra's playlist. It's like it explains things that you would have read in that book, and it kind of like couches them in pure mathematics. It's not like game dev specific, but it's actually quite useful to explain like some of the stuff you learned, like trivectors, bivectors, and regular vectors. So it's like it's all this kind of stuff kind of building on itself. Like how do you multiply like bivectors, which are just like space together, right? Anyway, yes, I will enough of the yap. But yes, Geometric Algebra is like this is a great series. I found it very nice anyway after reading that book, to solidify some of my knowledge. But I've forgotten some of the geometry stuff, so let's get on with it. Sorry, let me read some of the chat before we start, actually. Yes, when you read a lot of small chunks that are glued together. When I read more, my questions get answered. Yes, that's I'm glad they get answered. Yeah, apart from the advanced algebra, from it is 134, but yeah, it's not that bad. How do you build your roadmap? Like, what things did you consider to make it a good one? I say so. My full roadmap may not come out, but generally a lot of it came down to, when I was kind of going through this, was picking out free resources that people could actually just do. And generally I started out with like learning C++, because I don't know the other languages. I can't really tell you how to do that. Expectations and how to learn, because a lot of people assume that they can just spam AI over and over again to get a answer to something, and then assume that they've learnt it, and then forget it the next day. You know what I mean? So it's like a lot of it was like neuroplasticity, like what that means and what it feels like to be neuroplastic. Spoilers: it feels uncomfortable, and you're in a constant state of mild confusion. Yes, it doesn't feel good to learn. Like literally, it's not a pleasant experience if you're right in the middle of your brain rewiring. Anyway, so yeah, it was like a lot of it was just, if I was to give a junior programmer this is the general ethos that I went through. It's like, if I was to hire a junior programmer to help me with my game engine, like what would I like them to know, or what would I at least train them to learn as a junior programmer? So that's why I kind of went through, if I was hiring you as a junior programmer, I would probably, a C++ anyone, for C++, I'd probably like give you interview questions based on these topics. I'd be like, you know, when should you not use a pass by constant reference in an argument in a function, right? Like that would be a question I would ask you as a junior programmer. Like when is it less efficient to use a constant reference when you're using an argument, right? Like, you know, how much stack do you get to start with? What does a stack overflow mean? You know, and I would be like, okay, so what is the difference between composition and inheritance? And I would expect you to kind of like randomly understand these topics. Not completely. Like I wouldn't expect you to get every single question right, but that was my approach to this would be like, if I was to hire you as a junior programmer, like I would want you to at least understand what a template does, not necessarily like how to write concepts or anything like that, or even understand S4A. Like let's not go with S4A or anything like that, but like, can you understand like what a lambda does? Like why? What are the capture? What's the capture clause and the lambda do? Like what's the difference between the capture clause that's by copy and by reference? You know, like all that type of things. Like that's what I would be trying to like. Asking you about, so you could, you know, I could at least hand you some software and then like you wouldn't blow it up. So yeah, that's what I was thinking when I was like going through this roadmap. Meow, everyone. Hello. We're just talking about the roadmap that I was coming up with for people to learn. But yes, it would be, if I finish it, it'll be like you would be as good as me, starting from a junior position if you were to follow everything. Maybe I'm still a junior. You know what I mean? I don't know. I don't have any, like I said, I don't have any success to point to. Say like, well, look at this, guys. I did this really cool thing, and you should listen to me. So at the same time, you know, it's all like, I'm a bit iffy on if I should even make it like public for people to follow, because I'm not sure if it's going to be relevant. Anyways, let's study game dev maths, right? Game dev maths time. So like I said, this might be a bit of a drier live stream, but I hope you're all here for it and up for the co-worker vibes. So this is the what I'm going to do as well, just for the people who have never been to a study stream before. I will just read this out loud, take notes, and as I go through, people can ask me questions about this. But this book is not for free. I feel like it's okay to stream it. This is my justification, because it's not. I'm not going to be going it from top to bottom, and I'm probably going to be going around and clicking on other things. So yeah, if you do want this book, please get an actual copy, like I have. It's not too bad. It's definitely worth it. It's not too expensive. Sorry. And if you can't afford it, I understand it. You know, currencies don't work well. You know, transfer. You know, if you go to a different country, this might be extremely expensive, and I am pathetic for that, so you know I do understand. So yeah, let's maybe get some water and let's dive into it, because I've forgotten how this works. Right, so I'm just gonna call this. So yeah, like I said, gonna start on chapter 3. Read through some of this that I kind of already know, and only take notes when it's actually relevant. Okay, so geometry. Most of the computation performed by a game engine involves some kind of geometry. Geometry defines the world in which a game takes place. Geometry describes the characters in the game and their movement. Geometry tells the graphics hardware how to render a scene. Geometry also allows an game engine to determine what's visible to the camera. And geometry is necessary for determining collision between various objects. The list of areas in which geometry plays an essential role in game mechanics continues without end. After a short introduction to triangle meshes, this chapter will discuss the details of several basic geometric topics that are fundamentally important in game development of more complex systems. Hello, Matt. How are you doing? We're just reading a lovely book here. So I don't think we need to write any notes on triangle meshes, but we'll see. I'll just kind of write this down as a prep. Yeah, it's a bit more of a chill stream today, Matt. Feel free to ask me, by the way. I feel like I need to pin this, but I think I will. Because I might just be reading and people might not want to do this, but feel free to ask me what I'm working on. Yeah, because I just want to make sure that everyone's kind of let me just pin that, because I don't want to feel like I'm what is it called, like I don't know how to describe it. I just want to make sure people, you know, feel welcome. Effectively, that's my goal here. Doing nicely. Cool. I just came back from a science museum. Ah, very nice. I hope you learned something and had a good time. Sounds like a fantastic day out, to be honest. Okay, so with the exception of cases involving exotic rendering methods, objects drawn by a game engine are composed of triangles. A triangle mesh is a collection of triangles that fit together to model the surface of a solid volume at a minimum. The data associated with triangle meshes includes a list of vertex positions stored as 3D points with floating point coordinates. Yes. In most cases, the data also includes an index list that contains a triplet of integers indices for each triangle in the mesh, specifying which 3 vertices define triangles boundaries. Yes. There is typically more data stored with each vertex, but aside from the mention of normal vectors in the next section, a discussion of the details about this additional information will have to wait until volume 2. So yes, that's fine. I hope you have a nice ice day as well. Thank you. Yes, I probably will, considering we have a lovely community here. So yes, very nice. As an example, consider the box shown in figure 3.1. It's a triangle mesh. Its triangle mesh is made up of 8 vertices, 12 triangles. Each of the box's 6 rectangle faces is divided into coplanar triangles, and this is, yes, coplanar stuff is something I completely forgot how to work out. Like, if something's coplanar is what we're hopefully going to be refiguring out today, which just means like something's on the same plane. And this is typical because the graphics hardware can directly process polygons cannot directly process polygons having more than 3 sides. If we nuke the sun, then I think the temperature will go down. Yeah, I feel you on that one, Ratchet. Yes, we need an ice day for sure, 100%. So yeah, as you can see, triangles. You're probably familiar with this. These are indices, not vertices. They're being labeled, but they're both in this case. So yeah, so we can refer to this as 2, and we don't have to reuse it multiple times. If we hit the same thing, it reduces space. Anyway, there's always multiple ways to break down a polygon, having at least 4 triangles into vertices into triangles. The particular choice of triangles composing an entire mesh is called triangulation. Very nice. What is a triangle? What is the definition of a triangle? Isn't it literally a 2D polygon with 3 points, where each angles add up to 180 degrees, and it holds true for the triangle inequality that the sum of the base is less than. Sorry, yeah, is always less than the sum of the other 2 sides, or something like that. Right. Okay, the fact that it's a funny question, but it is actually it is actually kind of useful to kind of remember that, like what the triangle inequality is even asking. Anyway, the fact that there are fewer vertices. Sorry, the fact that there are fewer vertices than there are triangles demonstrates how each vertex is shared by multiple triangles. In the box shown in figure 3.1, every vertex is shown by either 4 triangles or 5 triangles. 5 triangles? Oh, I see, yes, because this connects to 1, 2... Sorry, The fact that there are fewer vertices than triangles demonstrates how... Yeah, okay. Each vertex shares multiple triangles. Yes, okay. I didn't quite get that in my head. Just read it weird. It is not about the sun. Enterprise goes crazy in production. Yeah, I guess so. If the sun goes out, it might be very scary or not chilling, but also cool. Yes, very true. I think the later two always hold. I think the later two always hold for any 3 points. Oh, you're talking about the triangle inequality? Yeah. Yeah. I think you're right. It's not like you have to choose a particular side. I think the triangle inequality, it doesn't matter what side you pick. Even if it's the smaller side, it still holds true if you pick. Yeah, that makes sense. If the I think it's called the triangle inequality theorem, which sounds really complicated, but it's just it's just an inequality. If the sun goes out, life goes with it as well. Freezer era. Right, I'll leave you guys to discuss what the consequences of the sun. Just nuke it. Right, while I worry about triangles. I'll finish this paragraph at least anyway. But yeah, maybe AI can save us. Maybe that can make a new sun. Right? AI can do anything, right? Save the world. You can AI a new sun. Anyway. Can you tell I'm being a bit facetious there? The fact that there are few... Yeah, okay, so we read that. In this box shown in figure 3.1, every vertex is also used by 4 triangles or 5 triangles, but it's possible to arrange triangles in different ways. So some vertices used by a few as 3 triangles, and other vertices are used by as many as 6. Okay. Sometimes an application will store a list of triangle numbers with each vertex, so it's easy to demonstrate. Easy to determine which triangle makes use of any particular vertex. This information would ordinarily be used for editing purposes. Okay. However, not in the course of actually rendering a model. Yes. If AI creates a new sun, we call it a daughter. Exactly. What's funny is that the sun is a big nuclear fusion reactor. Yes, 100%. Yeah, lol. Yeah, I think I watched a Vsauce video back in the day that if we threw a sun's worth of water at the sun, it would just be a bigger nuclear fusion reactor. It would just get bigger. It wouldn't be put out or anything. Anyway, this information. Yeah, okay. So a triangle mesh is called closed if it is the case that every edge is used by exactly 2 triangles. Right. Okay, makes sense. That is for any pair of triangles used by 1 triangle. There must be one more triangle, and no others that also use the same pair of vertices. Yeah, fair enough. For one of its edges, but does not share the... Okay, let me read this again. That is for any pair of vertices used by 1 triangle. There must be one more triangle. Yes, okay, right. So there must be another triangle used by another vertex. Okay. This isn't too important, I don't think, so I'm not going to stress about this. And no other... and also use the same pair of vertices for one of its edges, but does not share the third vertex with the first triangle. A closed mesh must satisfy the Euler's formula, which states... Yes... I guess I should learn the Euler's formula. I kind of blasted through this last time. So a closed mesh. I think it's going to be easier to understand the formula than the English that it's trying to explain it with. A closed mesh must follow the Euler's formula. Another thing that was named after Euler. Many, many, many things are named after this fella. Which states, it's very, very elegant as well. Alright, so I can use LaTeX. I don't think it's going to be that hard to write out LaTeX. It may be a bit weird when we get to linear algebra, but... sorry, geometric algebra. Euler strikes again. The Euler formula, exactly. It's actually pronounced Euler. Am I saying it too E-like? I don't know. Really? Euler. Oi. Okay, yeah. Why is Euler... Yeah, I don't know. I feel like Euler was like either a massive fraud who was just taking everyone's work, which would be funny if it was. I highly doubt that's the case. He's just like robbing everyone's equation. Yep, that's mine actually. I invented that. Yep, that was me. Or he was legit like smarter than Albert Einstein when it came to discovering stuff. Oilist. I like it. Anyway, where V... Okay, so yes. So where V is the number of vertices, E is the number of edges, and F is the number of faces. Okay, so if you have... so E... Let's write these down real quick. E... I think I can just kind of do this from... So V is the number of vertices. E is the number of edges. It'll be nice to have this in my notes at least, and because I don't actually remember this off rip. What I haven't done. F is the number of faces. When we talk about the number of faces here, we mean the number of triangles in a mesh. Ah, yes. In game dev, we are only talking about... Sorry. In game dev element, when we talk about faces, we are only concerned with triangles. So when we're talking about faces here, we number of triangles in a mesh, not number of faces belonging to an ideal solid. Likewise, the number of edges is the number of boundaries existing between all pairs of adjacent triangles, even if the triangles are coplanar. Yeah, coplanar, right? Whatever. Even if triangles are coplanar, we are talking about call Phoenix A at once. It'll wipe out everything. Yeah. My teacher pronounces Euler the same way as you do. How I feel like I'm pronouncing it the same way. Euler, like oil, right? That's how I say oil. I just say oil, oil the same way. How do you say oil? I'm just saying Euler, Maybe it's a British thing, I don't know. There's a joke that mathematics are named after the second person to find them because Euler was first. Yes, I like that. Yeah, because honestly, you found so many things. Lol. E to the power of x named after Euler. No, not Euler's x. I like that. Euler got married twice actually. I see. So we must have discovered two Euler's x's. First wife passed away at like 40. Oh, that sucks. Oh well. Well, It is what it is. It is what it is. Right, so let's, what I'm going to do is just, going to randomize this playlist, because it's just going to play it's going to play Fury over and over again, which I don't mind, but it gets a bit tiring for the ears. Let's close this. Does anyone want a link to this, by the way, this Essentials of Game Mathematics for Aspiring Developers? I'll post this in chat. This is just, you know, if you want it. Where's my live stream? So if you want it, guys, super. A very nice intro to game dev maths. Right. So yeah, if you want it, there it is. Just before I close it, because I was talking about how to study maths earlier. That's like a nice introduction. Yeah, feel free to watch that. Again, you'll need to know a lot more than that, but it's like, if you don't know some of the trigonometry, for example, it might be worth like studying a bit of trig. Anyway, if triangles are coplanar, there we go, coplanar, that's one. We are talking about, we still count those edges. Interesting. All right, cool. Yes, there it is. And I'm saying game dev maths here because this is not rigorous even a bit. It's like pure in application. Okay, so whereas an ideal box has 8 vertices, 12 edges, 6 faces, the triangulated box in figure 3.1 has 8 vertices, 18 edges, and 12 faces. Yes. Both sets satisfy the equation in 3.1. An important property of triangle meshes is winding direction used by triangles. When a triangle is viewed from the front side, which is the side facing the mesh's exterior even, we have a choice as to whether the vertices referenced by the triangle occurs in a clockwise order or a counterclockwise order. Isn't counterclockwise American and anti-clockwise is English? Anyway, either convention works equally well. Because the graphics hardware lets us specify which convention we are using. But we have to be consistent over an entire triangle mesh for a variety of reasons. That includes normal vectors calculations. In this book, we choose the counterclockwise winding direction so that the triangles satisfy the right-hand rule. Very nice. When the finger of the right hand are curled when the fingers of the right hand are curled in a clockwise direction, the right hand thumb points outwards from a triangle. Okay, so L is, so we've got Y is down, X is sideways, and Z is pointing outwards. Okay. With that, oh no, we can do it the other way around. Actually, it doesn't matter. Yeah, so that's just pointing outwards. Okay. And counterclockwise is the opposite to a clock. So I'm looking at a clock face right now, just so I'm not very good at right and left. It's a dyslexic thing for some reason. Yeah, like you get glitches in your brain like this. Alright, yeah, so got it. We go from top to bottom in a swooshy action that looks counterclockwise. And none of this is visual, so in computer graphics, we like to compute sine and cosine from cross product and dot product. Yeah, exactly. Which I found interesting. Yeah, it's like when we're talking about the rendering equation, the angle of incidence is basically just a dot product between the normal vector and the viewing vector. I think it's the v dot n, and that's just a way to get the cosine of theta instead. Assuming that they're normalized, that's exactly what you'll end up with. In the figure 3.1, the lower left triangle is wound in the counterclockwise direction, which when its vertices are referenced in order of 0, 4. Okay. So, oh, I see. 0, 4, 1, right? So 0, 1, 4, 0, 1, 4, and then 1, 4, 0. Okay, and then I assume 4, 0, 1, right? 4, 0, 1. So yeah, we go that way around. That's anti-clockwise, which, yeah, for anyone who has a normal brain, that's incredibly obvious that it doesn't need to be specified. The rendering equation. Thank you, TT. Dun, 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 dun. Thank you for the epicness. Right, I'm gonna hop over to the sample chapter actually, because it's actually nicer rendered nice, just a scanned. Yeah, I feel like I almost need to prove that I have this book in real life. I might actually do that later in the Discord just to actually prove it. Because I'm a bit, yeah, just put like a post-it note and say the year and date and my username. Alright, so we'll start with this because this is actually nicer to look at. 6, 7. Wow. There we go. Beautiful. Partial derivatives. Hey, finally can watch again. Damn. Had to migrate my engine editor from WPF. Ah, okay. To QC Quick. Oh, yeah, okay, right. Nice. I haven't had QC Quick in a while. Hopefully it's treating you well. Yeah, that's definitely an upgrade from WPF. I mean, WPF is fine. It's just dated. I don't know how well it's supported either. I know it's a great, but yeah, QC Quick will allow you to do a lot more things. I'm glad you can join us, by the way. Yes, we're studying a bit of maths today, so we're going to be doing the normal vectors, how to build up the lovely normal matrix is coming up very soon for nice handling of our lovely vectors. Okay, a normal vector, or just normal for short, is a vector that is perpendicular to the face, and direction in which it points is said to be normal to the surface. Okay, yes, a flat plane has one normal direction, but most surfaces aren't so simple, and thus have normal vectors that vary from point to point. Normal vectors are used for a wide variety of reasons in game engine development that includes surface shading, collision detection, and physics interaction. So yeah, a lot of this is you may be like, what the heck? This is super basic, but I forgot some of it, so I'm gonna be taking notes, on little bits. So yes, I'm not gonna be taking notes on everything because I do know like what a normal vector is. I just thought I would point that out. Anyway, there are a few ways in which normal vectors can be calculated. The best method in any particular case depends on how a surface is described from a mathematical standpoint. Okay. In this case, that a surface is defined implicitly by a scalar function of fp, the normal vector, at p equals xyz. So if we have a surface is defined, this is what it's important to kind of like, because it talks about this in anger in the next book. In the case that a surface is defined implicitly. Oh, by the way, the book I'm reading is in the description. I do own this book, so if you do want to own it yourself, give it a look if you're interested in purchasing it. It's just pure maths. There's no like I don't know how to implement this for your game engine type stuff, you know. In this case, a surface is defined implicitly by a scalar function. The normal vector at point xyz is given by the gradient f delta fp, because it's perpendicular to every direction tangent to the surface at point r, tangent to the surface of f at point p. Okay, so that's basically a really mathy way of explaining what a vector normal is. Let's see. Let me just type up a little thing before I forget. So the normal vector given a scalar function, fp, and the normal vector at position p equals x, y, z is given by I kind of want to get this like spot on though. I know this is like a super math way explaining like what a vector is, because a normal. So backslash delta. I hope that's going to come up with something. FP. Is that what that symbol? Oh, capital D. Yeah. Okay, it's upside down. It's the wrong way around. But because it's perpendicular to every direction the tangent that's tangent every tangent direction level to the surface of f at point p. Fantastic. Okay. It has a lot of support but no features, where Qt Quick has all the features you could possibly need, but you have to build most of the engine on your own. I have finished implementing docking. Yo, yeah, hell yeah, dude. Systems like Visual Studios are surprising. It was easy after doing all that. The memory usage in the task manager is sub 20 megabytes, which is mad, lol. Yo, that's awesome. 52. Gears Inc. Yeah, don't look at my game engine. It's currently at like a couple of gig. Or like at 1 point, no, that's a lie. It's like 1.7 at the moment because I'm reserving so much memory. Anyway, yeah, it's Qt Quick's fantastic. I remember when my first major job at my company was Qt Quick with Qt5. And what I had to do was build a renderer that was that could demonstrate its speed when it came to rendering 2D relative to just OpenGL. And no surprising here, the senior programmer that wrote the OpenGL renderer wrote a faster renderer. So we ended up going with just straight OpenGL and Qt, as the thing. But yeah, Qt Quick is really nice. It's like it's got like a nice like scripting interface. The only thing I didn't like in Qt5, that might be different now, but was the model view what is it called? Model view something. Whatever that is, that pattern I had to use was kind of strange. But the QC documentation is fantastic, and how you demonstrate how you actually do those things is actually really interesting. Oh, it's model view. What is it called? Let me Google it. You're probably familiar with it. I'm probably just saying model. It's 3 words. Model view pattern. It's like a design pattern. Is it model view? Is that what it's called nowadays? Model view controller? Oh yeah, maybe it is model view model. Yeah, it's probably that, but I remember in Qt calling it was called something else. Yeah, this is the idea though. This is the idea. Yeah, if it's a pattern. Yeah, if we read the not the AI. Yeah. This is kind of like the idea. It was a bit confusing, like when I was like brand new to like working professionally. I was like, I don't know what's going on. No, you made your own architecture for that. Maybe yeah, it's probably really smart. Yeah, model view control. I think it definitely was. Yeah, it was definitely 3 different words, which I can't imagine it's just mean the same thing. Anyway, yes. So that was a fun escapade down memory lane, hearing about QC Quick again. It's always good. I hope it ends up really cool. Okay, what have we got? Okay, so the mathematical, for example, suppose we have an ellipsoid illustrated in figure 3.2 defined by the equation. Okay, that's how you make an ellipsoid, hey? That might be useful for our collision detection, actually, so it's probably good that we... Example, if we have an ellipsoid, so I'm actually going to copy this over. Because ellipsoid is something I'm considering for my game, where I use an ellipsoid rather than a sphere for collision detection. Unfortunately, we did not nuke anything. Sorry, Ratchet, the sun is gone. Yeah. It'll take a couple of minutes to update, but yeah, it's going to take about 8 minutes, and then you'll see no sun. I feel like architecture spreads your functionality out too much. Yeah, that's what I feel like. With I mean, it's fine. It was used when I was like learning how to use Qt Quick. It was a lot of the demonstrations were like for mobile at the time. So it wasn't really concerned with like, cache locality or anything like that, to be honest. But that, it might have changed by then, Qt Quick. So this is how you write an ellipsoid, hey? Apart from that, though, it's chill, It makes sense, actually. This is basically a... I wonder if the collision detection is harder, though. That's the question. I can see exactly this is just a sphere if you did the divide by 4 differently. Okay, so the point P equals... Alright, so we got a couple of mad things in here to write out in LaTeX. So we have Squirtle. Gotta write Squirtle here. Backslash 6. But again, like the stuff that I was doing in Qt was like, it was a Qt. In 2019, it was probably Qt 5 was relatively new. It was like Qt 5 like 4, like when I was writing Qt Quick code. So, like I said, it could be all different now. I have no clue. This and this. Let's just make this 1 again. In the middle. Alright. Did we? Yes, we did it. Okay, fantastic. Thanks, Halia. Yeah, the sun will affect the trout population. That's the only thing it'll affect, to be honest. Yeah, so you don't have to worry. Everyone else. Lies. Oops. On the surface of the ellipse. Yeah, this is the stuff I kind of glazed over when I read this for the first time. I do recommend anyone who is serious about this definitely take notes, because you'll forget like I have. On like some small things that kind of make things harder to learn in the future. I'm just going to go with probably a vec n, like that, at the point by given by. So we have a lovely partial derivative here and a big bar. Okay, so let's see how we can write this in LaTeX. Okay, LaTeX programmers, let's go. Right, so n equals, so I'm just going to go delta again. I don't know how to do it upside down, so that might trip me up later, but if it becomes an issue later on, I'll change it. So we want left and right, and then hopefully if I put something in the middle. How do I make these big? Oh, actually, I haven't even seen if it's going to work first. Hang on. I think it's left and then right. Something. No. Bear with me just a moment. So I just want to make sure this is like easy enough. Graphics theory. And I started to correct my LaTeX when I found out how to do this, but I've forgotten how to do it, which is not good. The one after this. Let's see. Monte Carlo. No. Where's the thing gone? Estimate is... No, it's just before that one. No. Seriously? I clicked on the same thing. I swear I fixed it. Anyway, let's reach out real quick. Check Houdini's 22 keynotes at 11:21. There is a big trigger that made me jump from WPF to Qt Quick. Yeah, okay. I don't plan on using it either, but you know, might be worth checking out. Thanks for the resource. Why would you? Why would the point? Why would the point lie like that? Isn't it latex? Oh no, am I saying latex? LaTeX. Yeah, I'm sorry if I am a. I thought I was saying it right, then I realized. Okay, no, that's right. That's wrong. Okay, I'm just gonna. Forget it. Okay, this is unimportant. This is like a. Who cares? Who cares? Who cares? If it's right and left, if it's not big or whatever. Anyway. So frack. I feel like I'm taking too long. Yeah, I typically say LaTeX, but I could have been saying it wrong the whole time. Don't put it past me. I'm classic for going. That's not what I said, and exactly what I said. You know. So delta. I don't know why it's defined this way, but this is the problem. If I don't study how this book wants me to, then like it's confusing when I move on to the second book, and it's like, oh yeah, I expect the syntax exactly. Yeah, this is fine. It's not too much of an issue. I don't know how to do this bar though. Subscript P on this bar. Okay. Is equal. So we do some partial derivatives. Because we're using, I think we're going over x, y, z, so we don't do the full derivative because of that. 2x fracking hell. Yeah, so apparently when you do the partial derivatives, over this function surface, which is an ellipsoid, for point P. Given the point P is this is the original point. Yeah. Okay. So I'm just like remembering what we're doing here because I've spent so long trying to search how to do latex stuff, which we don't care about really. It's not that important. All right. So let's not get the deltas in. Right. Okay. So Squirtle. Put that in there and 6. So we have 2 after that. Fantastic. 2 and so this would be a correct. I guess if you were to do this analytically, this is what you'd have to do. Seems a bit overkill, but whatever. Oops, not 12. And finally, here we go. Point this would be that fella. Fantastico. Okay, cool. And Ellie spat my water everywhere reading that ratchet. the big point is escape points mob boss name. Yeah, that's it. To be honest, I thought latex was pronounced. Oh my goodness. I don't know which one's which. This is a trap. Latex, not latex. I don't know. This is like GIF versus GIF, right? But we all know GIF is correct. So, yeah. I don't know why I said that. Anyway. Calculating normal vectors with gradient is something that's usually done only in the process of constructing a triangle mesh to approximate an ideal surface described by some mathematical formula. Okay. The normal vectors, yes, we normally don't do this. I'm going to say normally oops, what am I typing? Normally, we don't do this outside of modeling software. Yes, modeling software. Modeling software which approximates. You know, it's a maths book when they say approximate. I've literally never read that anywhere else. Admittedly, I don't really read that much. Ideal surface described by some maths formula. All right, so we don't have to worry about that really, basically. I end up saying GIF, both GIF and GIF. Yes, correct. I like that. How hard is game dev? I'm an AI/ML researcher. Well, it depends. That is a difficult question to ask concisely. I would say very difficult, but maybe I'm just not very smart, and other people could easily do this. But game dev is a huge field, and there are 3 main aspects to it. There are game designer, game artist, and game programmer. I assume you mean game programmer, and when you mean game programmer, I assume you mean the subfield of that, which is game engine developer, which is what we're doing here, right? That is very difficult, and anyone can learn it though. It just takes a while. That's my small answer without opening Pandora's box on like literally everything. You could definitely do it. You could definitely do it if you were interested. Yeah, game dev is brutal. Period. Luckily, coding has been solved, so you don't need to worry about it. Yeah, that's true. Make the perfect game. Make AI. Make the perfect game engine. No mistakes. The normal vectors are typically scaled to unit length and stored with the vertex coordinates that are associated with comma. Oh yeah, with space even. with period even. What am I saying? Most of the time, a game engine is working with a triangle mesh, having an arbitrary shape that's created in modeling software, and the only information available is a set of vertex coordinates and a list of the indices that tell the vertices how the vertices are grouped into triangles. Fantastic. Okay, as illustrated in figure 3.3, the normal vector n for a single triangle face can be calculated by taking the cross product between vectors aligned with two of the triangle faces. Okay. Can you explain more about my game engine? I can show you that. Can I explain more about game engine? I can show you my game engine, I guess. It's like a 3D game engine. But I'm not exactly sure what you need. This is a very crude, rudimentary 2D renderer that's doing sprite sheet lookups for a very, very, very basic model. A menu. And then we have a debugged renderer. We have, a duck flying around, which is going to be a spaceship at some point, I think. But we'll still sneak in a duck, I think, somewhere. And yeah, we have nice physically based rendering, which uses the standard BRDF rendering to solve the rendering equation. We have two lights. We have a spotlight, and as things get lighter as you get closer to the asteroid, and a directional light, which I think looks nice in space. And we have some handling of entities. If you crash into a rock, as just tested right now, it will disappear. But that's not going to be in the final game. That's just to test something. This has taken a while. If you want to see my source code, it is in the description of the live stream. So yes, thank you for asking. I can't. I don't think I could give you like a huge introduction to game dev. That would require a large. So it requires maths to basically build the objects and lighting. Yes, it does. Yes. As you can see, we have maths going on here. The lighting calculations are written in a rendering technique called physically based rendering, which is like how the lighting works. You can do different. It's a particular lighting model basically. It's not the only lighting model, but because of that, it requires more maths, generally speaking. And yeah, that's what's going on there. But if you're an AI researcher, you're probably very familiar with maths. And maths AI researchers have to do a lot of heavy maths. So, you're probably familiar with some of the linear algebra, but maybe not. I'm not familiar with like the numerical programming which you have to do as for stochastic. What is it called? Stochastic. Yeah, stochastic programming. And for stochastic. For statistics, for computing that type of stuff, I'll say. I finally give my words there. Yeah. Anyway, triangles, triangle edges, P0, P1, and P2. Okay, so if you want to calculate the normal vertices, but yes, in short, yes, it requires a lot of maths. There's the game engine help for people making games more faster. I wonder if there's an AI engine equivalent to help train AI train faster with less compute. Maybe, yeah. I don't know. I'm not an AI researcher myself, so that'll be a good question to ask some. But I'm sure they exist out there, considering how much money's in that field at the moment. Anyway, so if we calculate the normal vertices, sorry, if we want to count the normal vector, we can use the triangle's vertices with a cross product. We just have to create Are these tangent vectors? That would be a tangent vector, right? I'm going to say tangent vector, unless someone shouts at me and say that's not what a tangent vector is. But it's tangent to the surface, right? Or tangent to the vector. I always thought tangent vectors were literally orthogonal to the normal vectors, so they were basically aligning with the surface. And okay, so we have. So let me write this out, and I will see how we get. So vec n equals. Oh, I love this song. This is like so good. It's truly a peak. Times p underscore 2 minus p underscore 0 comma, I mean brackets. Fantastic. I do AAA games with high quality shaders usually build on top of existing engines, or depends on the company. But yes, most major AAA studios that you're familiar with use their own game engine. So is there a release? So is there a reason to build your own game engine, or just learning purposes? There's well, for me, I do it for the love of the game. I love this, so I do it for that reason. Outside of that, I would like to make my game with my own tech as an expression of my, I guess, artistic process, to be so pretentious. So yes, those are the two major arcing reasons why I'm doing this. Yeah, so any permutations of the subscript that keeps them in the same cycle order produces the same normal vector. It doesn't change which vertices you choose to subtract from the others, as long as the first factor in the cross product involves the next vertex in the counterclockwise order. Yeah, okay. If the order is reversed, then the calculated normal vector lies along the same line, but it points in the opposite direction. Yes, okay, so that's pretty straightforward of saying. If you do the cross product differently, you can end up with a normal vector that faces with inward. I think it's just the anti-commutative nature of cross products, but let me say it doesn't. As long as the first two vectors of the cross product involved in the next. If you want to make sure that it's the correct way round, pick so the first subtraction of points should be chosen in counterclockwise. Oh, and I'm going to say anti-clockwise because I'm English. Anti-clockwise direction, baby. Fantastic. Okay. Hi, just curious. Are Vulkan games like Dota 2 developed use their own game engine? Yes, I believe Dota 2 will be using their own game engine. I'm not exactly sure what they're using. But there are, yes, most game engines don't use Unreal or Unity. Sorry, most game studios don't use Unreal or Unity. So yes, and they'll be using Vulkan or something like that, right? It's not always true that they're always using Vulkan, but I'm not familiar with Dota 2 specifically. But yes, they'll be. It's more efficient in general if you can get a specific game engine for your specific use case. The downside of that is it's slower to do development, but not always. Not always. Sometimes it's actually faster. It depends on. It really depends on the game you're trying to make, the expertise you have at hand, and your goals. Right. If you just want something out the door, like let's just say you're doing a port or something, like let's just say you're making Spyro the Dragon or Spyro 4, and your team's not familiar with a custom game, it would make no sense to make a custom game engine. All right, like Toys for Bob are making a Spyro 4, and that's going to come out on PC, I believe, and they're using Unreal. So yeah, it really is dependent. I'm not actually sure what Dota 2 is. Pre-made game engines don't work well in any genre. Yeah, compared to yes, if you can get a, like I said, yeah, it's basically what I said. It depends on the game, and typically, like for example, I bring this up a lot, but like Factorio, for example, that would work worse if that was in Unity, because of how it has to do so many sprites moving and scaling, and you've got to be able to build a humongous factory with lots of things moving all the time without the frame rate hitting 0. So, that's kind of tricky for, non-custom game engines that don't care about that specific use case. Whereas, like, general game engines have to incorporate, like, the most generic kind of game to support the widest user base. So yeah, that is the downside and upside of using game engines, I guess, and not using game engines. All right, so for some reason the music has stopped and it's also repeating. So yeah, let's pick some random. Let's pick a lone fighter real quick, so it stops repeating itself. Oops, no, we do actually want this. Okay, so anyway, let's keep on keeping on. Let's go. Some single developers will have multiple engines like Nintendo. They do share some libraries. Oh, I didn't know that. But that makes total sense. Yes, it depends on anything, right? Anything and everything. To calculate per vertex normals for a triangle mesh, it is typical that game engine models process pipelines to calculate all the preface normal vectors and take advantage of each vertex over the whole face that use that vertex. Okay, so the average may be weighted based on the triangle area or other factors to create a smooth field of normal vectors over a curved surface. In cases in which a hard edge is desired, such as for a cube or a pyramid in figure 3.3, vertex positions are typically deducted. Okay. And different normal vectors corresponds to different faces, which are associated with the various copies of a vertex coordinates. So, okay, got you. So, right, okay. I'm just going to say that's fine. That's just how it's calculated. Hi, Dimitri. Gotta go. See you, Matt. Have a good rest of the day, whatever you're up to. See you soon. Thanks for joining us. The normal vector n for a triangle face having P123 given by the cross product between... Okay. And... Fantastic. Okay, that's fine. Yes, I think that was fine. We don't really need to go into any depth on that, really. For example, Breath of the Wild uses a completely custom game engine called King System King, I see, which isn't used in any other Nintendo game. Makes sense. Kalia, it's not really clear what's stopping you from diagnosing someone else's game engine. Profilers show everything. Oh, I see. That makes sense. Yes. There is some truth to what Dimitri's saying there. Sometimes something is slower, something is faster, right? The only real way to figure out if something's slower or faster is to profile. At the end of the day, that's what Dimitri's saying there. Sometimes Unreal will do what I'm doing way faster because they're just doing it better, and the only way to real figure that out is profiling. And that's being a good engineer, thinking that way. Just found your channel and love your content. I appreciate that, dude. How do you go about studying programming? How many hours do you do a day? Well, it depends. I've kind of crashed out recently. I was only studying for like 1 hour, but typically I've been averaging 4.5 hours programming, and not just necessarily studying, but like programming and studying. I've been hitting 7 or 8 hours recently, but that was like before. I'll show you. Pause this for a minute. So we've done like an hour outside of talking, and you can see I hadn't done very well these past couple of days because I was working on other things and kind of we can get into it if you're interested, but it's anyway. So yeah, but like 7, 6. I have an Excel spreadsheet that kind of goes over like literally everything. So yeah, we should call this maths actually, not game development study. But anyway, let's change this real quick because this is maths. I've looked at this. Yes, we're actually just doing maths today. But yes, I do have a I'll just show you to prove, I guess. It doesn't really matter. If you don't mind staring at my email for a brief moment, I will show you my Excel spreadsheet. So yeah, I basically just write down all the hours I've done over the like years, and I've averaged them up to say last year was okay. So I've got 2 years here because I started a bit later. I started in 2024 November, recording my time, and I averaged 3 hours and 21 minutes. I'm currently averaging 4 hours and 25. And this is just like, this was just mostly for the video that I made of like programming for 1,267 hours. Yeah, that was, because it would have made less sense if it was like, I've been programming since November the 20th of November, 2024. It's a bit less useful, I think, to the people who would be watching. So yeah, that's what I'm averaging at the moment. That's what I'm averaging. You don't have to average that high or that low. I don't know how you would rate that. I don't want to like intimidate you straight off the bat and say like, oh, you need to be studying like crazy. But I would say that the more you study, the faster you'll get good. And yeah, that's what I do. But yes, I think since I've been doing it more recently, outside of these 3 days where I haven't done that much, I've made so much more progress. So I know it seems kind of trite to say this, but the longer you work on something, the faster you'll get things done. But yeah, thanks for joining our stream. Hopefully that was a nice aside. Now you need to be programming 17 hours a day for 17 years straight. Yeah, exactly. That's the only way to get good. If you're talking about game engines that don't have debug signals, then you shouldn't. Yeah, makes sense. No access is not made for you, 100%. 2 to 4 hours a day. Yeah, that's like a good amount. I do not understand what you mean. Well, I'm just going to read out Dimitri's stuff because Dimitri's coming out in Russian. So even if he's talking to someone else, I'm going to hopefully read that out so you guys can know what he's saying. So Dimitri has said, I've been using the same game engine for years now. I used this profiler to find places where it was lagging and fixed it. Oh, well done. It's someone else's engine, but you can diagnose it. Dimitri has also said, there was a cool bug. Emojis caused a file search for font glyphs, which is kind of a death, a slow death. Yeah, nice work, dude. Nice work, Dimitri. That's awesome. I've been getting back into programming after being in healthcare for a while. Oh, cool. I hope you enjoy your journey back. And yes, I would say if you're worried about AI, don't worry about it. I feel like this is just for people who are programmers. I take it from a programmer. A lot of the AI hype when it comes to like you're going to be replaced is just salesman's talk for companies to end up buying their software, right? So don't worry about that. That's a lot of that. What you're hearing is if you do hear about AI taking programmers' jobs or anything, it's a lot of salesmen's pitch, to try and sell AI. So hopefully that gives you some encouragement, and yeah, don't get knocked off your path by salesman speeches from these AI companies about how programming will be made redundant in X amount of time. Anyway, let's continue. When a model is transformed by a matrix in order to alter its geometry, every point P belonging to the original model becomes MP. Is transformed the model. Okay, yeah, that makes sense. Since the tangent vector T can be approximated by the difference between points P and Q on a surface. Have we skipped a thing? Am I tripping here? A 3 point? No. Okay. I just know how to explain what a tangent vector is, and it's just saying this is what it is. Okay. Or is exactly equal to such a difference. It is transformed in the same way as a point. Becomes MT because the difference between the new point PT and QT is tangent to the new surface. Problem arises, however, if you try to apply the same transformation to a normal vector. Right, okay, so that makes sense. Tangent vectors, I'm just going to say, is very simple. Tangent vectors aren't affected by a matrix transform because they are calculated based on the positions the vertices vertices. What am I saying? I can't type anything today. Let's just quickly get rid of my horrendous spelling all of a sudden. Okay, great. Oh, is that how you spell vertices? I know, whatever. Based on the vertices of a model, meaning that when I'm going to kind of rearrange this a bit. I hate it when he uses Q in this book, honestly. So I'm just going to say P1 and P2 because it's easier to parse. And P2 are transformed by... Yeah, I'll use capital S for matrix M. Matrix M. Then the tangent vector T is just empty. Sounds like I said empty. Oh yeah, vertices. Yes, thank you. Yeah, thank you. Thank you, Marco Martin. Good to see you again. Okay, so Dimitri has said KDAB hotspot profiler is my favorite. Okay, that's something to know about. There is no need to go into detail about AI. It's pure psyop, yeah, pretty much. A trained dog is no substitute for a flexible, ordinary mind. I like that. It's a psyop. I mean, I'm not like I don't want to turn this into like get your pitchforks out and torches and burn down the building kind of thing. But you know, I just feel like it needs to be said for some people because it's especially new people because it's new getting into programming. You can get very easily discouraged. Right, I kind of already know what this problem is going to demonstrate, so I'm probably just going to speed through this. However, normal vectors. Oops. Can't be. Sorry, can't be affected. Transformed. Yeah. Transformed in the same way. Right, cool. Consider the shape shown in figure 3.4 and has a normal vector n on its slanted side. Let M be a transformation matrix that scales by a factor of 2 in the horizontal direction, but does not scale the vertices. Does not scale the vertex direction. The vertical direction. If the matrix M is multiplied by n, then the resulting vector Mn is stretched horizontally, as clearly visible in the figure. So Mn, that's it going that way. Cool. It's no longer stretched horizontally and is clearly visible. Is no longer perpendicular to the surface. This indicates that something is inherently different about normal vectors, and if we want to preserve perpendicularity, then we must find a way to transform them that produces the correct result. Taking a closer look at the matrix, at how a matrix transforms a vector provides some insight. Okay, so if we scale a model non-uniformly, this scales vectors. Normal vectors. That's vectors as well. Spelled that. Normal vectors in a way that destroys perpendicularity. Okay, cool. Fantastic. Okay, so if we take a look, don't worry about this, guys, when it comes to if you're transforming a model by position and rotation, this doesn't destroy normals. Only when you scale it, and only when you scale it non-uniformly. Because if it's all uniform, then it just kind of scales fine. Nothing changes the normal vectors. But this is important if you do have a non-scale uniform. It will break the lighting effectively. And you'll get kind of like a weird artifact where the light source doesn't hit it properly and it looks off. Anyways. So if we restrict our discussion to a 3x matrix, here, since normal vectors are not affected by translation, yeah, there we go. But the same conclusion can be applied to a 4x matrix in this discussion of planes later in this chapter. Fantastic. Okay, so yeah, it looks like we're gonna have to do this inverse matrix, but isn't this an adjunct matrix that we need to do? I hope it talks about an adjunct matrix, not a inverse transform, because that's what we need to do for this anyway. Okay, so let's read this figure out anyway. Figure 3.4. A shape is transformed by a matrix M that scales by a factor, of 2 only in the horizontal direction, as you can see down there. the normal vector n is perpendicular to the original surface here. But if it's treated as a column vector and transformed by matrix M, then it's not perpendicular to the transformed surface. So yes, when you're multiplying vectors, that's how you treat them, column vectors, as a column vector, otherwise nothing makes sense. Just going over what we've already read. Excuse me, I just sneezed. I muted in time though. The normal vector is correctly transformed. So the normal vector is correctly transformed by treating it as a row vector and multiplying by the matrix inverse. The original normal vector is treated in light gray on the transformed. Sorry, so the original normal. Okay, that's the original normal vector. The inverse. Okay, so that is perpendicular because obviously the right-hand angle. Does this actually bring up the adjunct matrix? Because I really hope it does. Because this is literally. Oh, there it is. Yeah, inverse. I'm gonna be very pouty about this if it doesn't work. Because if this is straight inverse, then I don't really want to write this down because this isn't. Okay, so there's the adjunct matrix, I think. So this is. I was just trying to think. Is there anything in here that's like? We do have an adjunct matrix. So this is gonna go like prove, I hope, that the adjunct matrix is the way to go with this for a normal matrix anyway. Because otherwise, it's gonna be a bit of a waste. Okay, there's only one way to find out, right? Let's just read it. I think at some point, I don't know when, probably about like in half an hour, probably gonna pick a video to watch instead, because I need to eat obviously, because it's going to be lunchtime soon for me. So for anyone who is here and is still listening, this is your warning. If you want to watch a video with me while I eat, feel free to pick one out that hopefully is game dev related. I would like hopefully anything that you found interesting that's kind of relatively short, otherwise we can't watch the whole thing. So if you found like a cool vid that you want to share that we can watch while I eat, you know, feel free to post it in the chat and I'll consider it. Yeah, if it's game dev related, that'd be awesome. Programming related is also fine if it's just like how software works. But yeah, I would like to still be like a productive session while I go on push to talk. We lost a lot of time here, but that's fine because we didn't time ourselves. But anyway, okay, so yes, there we go. If not, I'll just pick something. There's no pressure, by the way. I often pick something anyway. I just thought I'd open it up to the floor. Okay. Anyway, so let's vector A. So let VA be a vector whose coordinates are expressed in a coordinate system A as indicated by the superscript, and consider that the fact that the components of a VA measure the distance along the coordinate axis. A distance delta XA along the x direction in coordinate A is equivalent to the sum of the distance A delta AB, sorry, the sum of the distance in delta XB, delta YB, and delta ZB. A Game Maker's Toolkit and AI in Games have some great videos on game design and game AI. Okay, yeah, we can. If if that sounds good, I'll watch Game Equals Toolkit, and we'll stick that on. Thank you for the suggestion. Yeah, so in half an hour we'll give that a watch. Thank you for the suggestion. Okay, cool. Along the axis aligned direction in another coordinate system B. Okay, so fine. The x component of xa can therefore be expressed in as a vector. What is this going on about? The distance of delta xa along x direction coordinate system A is equivalent to the sum of x, y, and z along the axis aligned direction in another coordinate system B. Okay, is this just true because it's a definition? Or is this true because something else? This is the problem with math sometimes. Sometimes it says something and it's like, okay, how is this true? But it might just be definitionally true because it's the axiom of which we're working with. Let me work backwards a minute. Okay, so let VA be a vector whose coordinates are expressed in a coordinate system A as indicated by a subscript. Okay. And consider the fact that the component of VA measured distance along the coordinate. Okay. Squeeze that the components of VA measure the distance. Isn't this just the definition of a vector? I don't understand. Isn't that literally telling me what the definition of a vector is in some coordinate space? It's like defining what a vector is. Like, yeah, each component is a measurement of its distance down a coordinate axis. Yes, that is what a vector is. A distance delta xa along the direction in the coordinate system A is equivalent to the sum of distances. Okay, so this is just a definition of what we're transforming to, I think. All right. Okay, so I think this is being a bit more mathematically rigorous than I care to write down, due to the fact that I think it's going to prove that what this matrix is going to do. Sorry, what we're about to do is this. Like this, for example, all this here is going to be true based on that definition. So I don't really care how we get there as long as it gives us a result to work with, because I'm not really a mathematician. Okay, so anyway, along axis aligned directions in another coordinate system B. Okay, so what I think is that this is A is a scale of B. I think it's just setting up the definition. The x component of VA can therefore be expressed as a vector. Yeah, so AX equals... Right, okay, so... Right, okay, that makes a lot of sense. This is just a definition that we're going to be working with in coordinate system B. Okay, so I'm going to kind of simplify that down without all the fluff. Okay, so if we... Okay, so that's the problem. What are we doing here? Transforming... I'm going to say building a normal matrix. Normal matrix. Fantastic. Okay. Cool. Okay, so if we have a vector, again, I'm just gonna... I don't mind. Should we do vec A? V, and then subscript. I'm just gonna do this like A, right? Cool. Okay, it's a bit big. Yeah, I'll do subscript rather than superscript. Doesn't really matter. Where if we were to transform yeah, I'm just going to copy this by matrix M then the x. Come on, x, there we go. Of vector vector add up to, I think I've wrote that slightly wrong. No, I did it slightly wrong. Yeah, let me that's yeah, okay, anyway, adds up to the total length of x underscore b. Oh, I'm gonna do a vector here. Vec. Fantastic. Ooh. Okay, b. Yeah. Okay. I think I'll do like this. Is actually better. I'll write this on the right side because it's nice. And I need to make this Z. And where's the Z button? There it is. Equals. Oops. Equals x underscore a. So that's what that is. Note. This is just used to make a mathematical point, not something that's always true. So yeah, we're just going to make a mathematical point with this. We can express vec b vec underscore b as a the x component of vec b can therefore be expressed as a vector in using vec b. Sorry, this is like super confusing. Let me I'll explain this maybe after. In the b coordinate system. Fantastic. Okay, so I'm just going to write this out. And I swear this is just left. And then right. No, it really isn't. I wish I knew how to do this, because this is... Ah, there we go. Okay, that's how it's done. Finally. Okay, so let me just write this out, and I'll... yeah, we can have a little discussion. So delta... so I don't lose my place. Delta? Delta! Okay, capital D. And... x to the power of... Oh. Subscript. We're going to use subscript. Okay, so this is going to go a bit faster once we've got it... once we've written the first few things out. It is a little convoluted at the moment, I do admit. Okay. Right, fantastic. A. So there we go, and finally we just need to do a vec, again vec v. Oh, hang on, we're gonna have to do subscript. All right, so that I believe is a. I swear this is how you do it. Okay, yeah. So we're just gonna have to do that. Yeah, excuse me for while I faff around with LaTeX. It is a bit hard to get my head around. Okay, so because vec3. Huh, okay. V underscore X overscore or subscript A. Okay, and now we can just lazily copy and paste this over and over again, which is nice. Comma this, comma that. We just change everything from so all the bottoms are X, X, X. Then we do this. This is still Z. Okay. What is changed? The only thing that's changed is the numerator. So that is the first thing after delta. So that's Z. Z. Nope, wrong one. Okay. X. Okay, so over here is Z maybe. Yep. And a bit further back than I thought. And Y. And Y. And this should be B. Yes. Okay, cool. Let me press enter. Okay, fantastic. Okay, let me catch up with the chatteroony. In your 1,200 hour video, I noticed that you used a lot of books and tutorials. Do you prefer to learn first, then build, or start a new project and research as you go? Sorry for the questions, lol. No, it's a great question. I will answer that. I just had to had to write a lot of LaTeX out to finish my thoughts. Okay, so yes, I used a lot of resources and books because unfortunately that is how learning process has to go. There isn't a continuous resource. It's not like there is a set roadmap that everyone follows, right? For example, you might know a lot of maths. I don't know that I don't know. So you don't typically need to learn all the maths that I would have to study. So there are two approaches that you can take, in my opinion, which are pretty good. And I mix both of them in. It literally is what you just said. It's instead of just doing, like, for example, a university course in undergrad mathematics and then a university course in undergrad computer science and then a university course in undergrad graphics programming, right? And then combining them all together finally after a couple of years of study and, you know, blasting ahead with, you know, making the perfect game engine. It's probably best that you do both. I've experienced that taking some time to study for a short period of time helps you by giving you what feels like a boost when you come back. It feels like you've got a buff, like in a video game, for example. So, like, for example, let's just say I studied C++ for like 2 weeks. I would then be able to come back to my programming and be like, oh, okay, everything's a bit clearer now. Everything's a bit more, makes a bit more sense. So I would recommend for anyone who's trying to get into game engine development or anything like that, start off by, if you've no experience at all, learn your language well. But at the same time, how you go about this is exactly the same way as how I study, how I would be doing things. Instead of doing maths, for example, I would, like, say, in our case, I use C++, so I'm only going to recommend C++. You can use other languages. I'm not going to say which one's better and which one's worse. You would learn C++ from learncbp.com, and at the same time, build a project that's, you know, very simple. And I think, do I have my games open? Like my first, I'm going to call it a game engine. Despite other people would not call it a game engine, this was my first game. You pick a number for difficulty, and then you just guess a number that the computer's randomly generated. And so it'll be like 250, right? It's too big, so then it's like I've got to go larger. I don't know, 775. That it's too big. Okay, so like maybe 425. Yeah, this would be the project that you would start on if you're starting from scratch. I don't know how beginner / advanced people are, but you know, this is the same idea, right? I would be doing this project, but it would also be at the same time taking breaks on projects to go to learn CPP, which is something I did in 2017. And I would be like, all right, I'm going to read this, this, and this, and then try to do something from one lone coder. I mentioned him earlier as a guy, but he also has fantastic. If I bring him up, he has fantastic beginner projects. Again, this is just an example of like how you would do about it. So, so I would go personally to his older videos and then pick like some project that you're interested in, like this FPS first-person shooter. I've actually written this myself. Sorry, I've used his tutorial back in the day to do as well, while I was like getting better at C++ and things like that. So, yeah, that's how I would do it. I would be learning and then doing a project at the same time. So nothing has changed. It's just I have to just bounce between different things, right, to continuously get better. And it all depends on you and your goals and what you want to learn and what you need to learn and your weaknesses and your strengths. So it's highly individual. I think it's better to learn as you go. Basically, you don't need to learn everything. Yes, that's generally a good idea, especially for people who are starting out. I think a hybrid approach is good, but I think that's also a very valid approach. Basically, you want, if you're starting out, again, I don't know how new you are, so hopefully you don't feel patronized. If you do, I apologize. But anyway, if you are new, it's like you want that instant feedback to keep yourself motivated. You don't want to spend 2 years learning maths and like have nothing. For example, you may be excellent at maths, but it's very unlikely that anyone who is going to like become an engine developer starts out that way. You want that like kind of like, okay, this is actually quite fun. This is, you ease yourself into it by like starting with smaller projects and like building yourself up. And you can take longer and longer study sessions as you know your skills and know your weaknesses and stuff like that. So yeah, that's the way I do it still to this day. It's like nothing has changed, and that's what I recommend to other people. Typical projects: progress, guess number, Fibonacci, calculator, 3D, your own 3D engine. I built many little games, over the years. I built Snake just to show you that I have actually built these tutorials. This is one of the tutorials from that YouTuber I just showed you. I don't know how to control the map. The Snake, I've completely forgotten to play this game. But yeah, it's like this is like a project that I would start with. And keep on. I said I made that ASCII thingy. I have made that FPS ASCII. How do I? Yeah, okay. So this is like a ray trace, well, a fake ray tracer. Like these are the projects I would start with. And you'll get better, assuming that you're learning like C++ from a website as well. So I appreciate the advice. I kind of resonate with your hybrid approach. I like learning though, learning resources, but I have to build stuff eventually. Yeah, exactly. Yeah. Yeah, you'll get there if it just takes years. That's the thing people don't want to hear, to get good, and I honestly don't feel good either. So, so it's I'm glad you like my advice. Yeah, I like I said, I do recommend a hybrid approach for anyone who's listening as well. Anyways, all right. So in the coordinate system B, okay, similar expressions with a delta A, delta YA, and delta ZA in the denominator can be used to express the coordinates in we can do the same for Y and Z as we did for X here. Cool. Oops. Nope. That was... There we go. Just a single. There we go. Okay. I mean, I'm not a computer scientist. I've studied telecom engineering, so I know some programming concepts that I don't really need 2 years of learning. Yeah, there's like it depends on the individual. Like, people have different experiences and different backgrounds. That means that they would not need to do absolutely what I've done exactly. CL utilities. Dimitri has said CL utilities are also a cool thing. Yeah, exactly. So, you know, you can build something that downloads something from the internet as a command line interface thing. Yeah, all great projects. All great projects. I would just recommend. I just recommend gamey stuff because I'm interested in games. You know. So I think they're great starting projects in my opinion. Okay, adding them up gives us a transformed vector B in a coordinate system. Okay, so we can build up a transformed vector. Okay, this is going to be interesting to write, to say the least. So B that corresponds. Okay, so hopefully after we've done this, we don't have to type out as much LaTeX to the original vector. I'm just looking at this like next thing I'm going to type out. Oh dear. Vec. Vec B in its entirely. This can be written as a matrix transformation. Okay, here we go. This is the big boy. We got it though. We got it. Okay, so V. Okay, so vec V with a space of B is equal to left. And then, how did I do this again? Where's the right go? Right goes right. Okay. So then, \right. Fantastic. Okay, right. I don't know how to do this, so what I'm going to do actually is I am actually going to do subscript of X. No, how do I do a matrix actually? That's a really good point. This is going to be a bit of an issue. Okay, so let's write out the first bit so we can just start copying and pasting stuff. So delta, forgot the caps again. Okay, so X, okay, underscore, oh sorry, over subscript thingy, oops, B is the same as the difference between that and A. Okay, so the problem I'm having here is how do I keep going? Because I'm just going to build a column matrix, sorry, a pure one-dimensional matrix. Let's see here. But sure, I've recently started building my own game engine too, and it's taking so much time. The temptation to ask AI is definitely real. Yeah, I understand that. I would say definitely stick with it, my guy. You'll 100% thank yourself in the future for not having to rely on AI to do stuff for you. I think it's going to be... I think... I said this in my guide for people who are curious. I wrote like a quick guide on how to learn Vulkan. It's not like a really in-depth guide, don't get me wrong. But I think, in my personal opinion, that using AI will sets a hard ceiling on your ability. So I'm going to say LaTeX, how to make a matrix. So that's basically my opinion on that. So that's why I would say like stick at it, because you'll eventually succeed the ceiling that, you know, asking AI excessively, not that you would do that, but, you know, asking AI in general, I think, sets for developers, because it has this effect where you don't rely on your own thoughts. You know, you kind of just go, oh, it's just easier to look things up. You know, it's the same way, like, you lose the ability, if you use a piece of technology, for example, this is just where it comes from, I think. If you use a piece of technology, how to do a matrix, you'll eventually lose the ability to do stuff. Okay, so it's just begin and end. Okay, so if I do begin, it's just again, it's just an opinion, that one. I think it just has end. Oh, okay, end. And then, but maybe we can discuss that after the video, hey, that we're gonna watch about AI. Okay, so I'll just read what Dimitri has said, because I don't think everyone can read Russian. Not that I can't. I've just got auto translation on. It's important for beginners not to get too bogged down doing in GUI. GUI provides a rather isolated experience. Okay, yeah, okay. The only with some experience should you touch graphical user interface. That's what GUI means, if you don't know. It's very stifling in basic C++. Only after mastering the advanced features can you enjoy writing some sorts of reflective templates. Makes sense, yeah, the reflective templates are advanced. All sorts of virtual crap too. Dimitri has said also, but I gained some more competence. I simply lost the sense of magic from writing. I simply lost the sense of magic from communicating with the bot. Makes sense, yes. AI takes everything. One question is this your personal project, or is it your real job? Are you talking to me? This is just a pet project. But I'm treating it like my job at the moment. I will have to admit. So yes, there is that. So I think I need to do matrix, and then matrix. No, I don't know. Get rid of this ampersand. Oh, okay, S, and then F, and then ampersand. So I'm just gonna put these in for like boilerplate, just because I want to see. Why is it not working? I'm gonna get rid of this, maybe. Oh, I see. I've made a mistake here. That's what the mistake was. Oh man, this is so confusing. Let's get rid of that, and that. Okay. So if I want to separate things, I need to do ampersand something, right? Nope. Okay, the first row is separated by an ampersand. The second row... Oh, is it backslash? Backslash? F? No. Nope. Okay. I'm so confused. Alright, I'm just gonna write this differently then. I didn't want to do this, but... so I'm just gonna do it as like a small matrix, aka vector 3 times. It's just taking too long. I'm sure I can figure it out when I come back to this. So I just need to change this to... Yeah, so it's just gonna take too long to figure out the LaTeX. I don't really need that level of like precision. So Y, and Z, I think is the only difference. Yep. Okay, so instead of... I just have to make a note to myself. Get rid of this matrix thing because it didn't even work. It's fine. Actually, I'm just going to ignore it. Y. Sorry about taking so long, guys. It's a bit of a convolution, I have to admit. Unnecessary complexity, I think, for this type of thing. Which we can just do this, right? Okay, so please assume that this... oh, hang on. I've got to write in this one. V... Make this a vector again. Vec and... Oops, wrong thing completely. Vec. V needs to go inside. V. And... A. Okay, cool. I think it would be easier to work out if I didn't have to do like delta, subscript, and superscript stuff. Calculation. You know what? What am I doing? It'd just make my life so much easier if I just did this. Like... Ta-da! Done. Okay. There we go. Actual brain activation right there. That was my Windows noise. Where is my... Let me see the image. I don't want it to be called image 2. Matrix mult 2B. Right. Yay. Yeah, I want to be able to refer to that in the future. Fantastic. Okay, so that was just a big bit of a waste, but hopefully... Alright, let's take a break. I think I need a break, right? Let me just catch up with chat. Just one last thing. Dimitri said, if you know that if I asked for a neuron something in a certain way, I will predict answer, which could be a hallucination, which is why then why I do go there and ask something. Yeah, why do I go there? Why do I go there and then ask something? Yeah, makes sense. That makes sense. Yeah, hallucinations are bad, right? That's the general idea. So let's look up this video, which was suggested by Philip. So I'll Google that briefly, and obviously I'll adjust the audio and stuff like that so everyone can hear it. And maybe we'll have a little discussion afterwards. I don't know. I'm in a bit more of a chatty mood, if you can't tell. Yeah, so let's type in Game Maker's Toolkit. I haven't watched him in a while, admittedly. So yes, this is so I can just eat. And what was it called? It was AI and games. Cool. What have we got here? So I'm going to say it's probably not This Is Good AI, which is probably about pathfinding and stuff. Oh, you're saying, and I understand. I thought that was Game Maker's Toolkit. Yeah, we'll just watch a Game Maker's Toolkit video. I understand now. I understand. I thought that was a Game Maker's Toolkit video. Okay, so these are fantastic. Yes, let's let's go with, how about this is perfect length for me. How about this, right? Zelda has changed everything forever. Let's go down to the bottom, and I will change this to this mode. Nope, there we go. And what I'm going to do is just play the video so I can adjust the audio for you guys. Okay,
so back in 2013, longtime Zelda producer.
Alright, I'm just going to grab my food and I'll be right back and we'll watch this together. Again, I'll go and push the talk so you don't hear me chew, okay? Generally speaking, that's probably a good move. All right, so see you in a sec. Stochastic. Okie dokie. Hope you all are good. Just went to the loo real quick. You probably could hear me. Right, let's refresh the live stream the video so it actually plays. Okay, guys, I will go and push the talk so you don't hear me chew and rattle cutlery. So yeah, I hope you all enjoy the vid. Let's go.
Hey, it's Mark. So, back in 2013, longtime Zelda producer Eiji Aonuma promised that the next big Zelda entry, coming soon to the Wii U, would completely reinvent the Zelda franchise. He said, "Our mission is quite plainly to rethink the conventions of Zelda. I'm referring to the expectation that the player is supposed to complete the dungeons in a certain order, or that you're supposed to play by yourself. The things we've come to take for granted recently. We want to set aside these conventions, get back to basics, and create a newborn Zelda so that the players can best enjoy the real essence of the franchise." And he wasn't lying. This next game wouldn't just shake up the formula, but it would fundamentally change how Zelda games would be designed, perhaps forever. Here's how it happened. So, by 2013, Zelda had settled into a familiar and formulaic groove. In each game, Hero Link visits dungeon number 1, finds some handy new item, uses it to defeat the boss, and open up the next part of the world map. Where he'll visit dungeon number 2, find a handy new item, defeat a boss, and, well, you get the picture. Sure, each Zelda game might have a unique world, tone, cast of characters, and clever mechanical gimmick. But this strictly linear structure had barely changed since Ocarina of Time back in 1998. It had become stale and a little bit stinky. And it all culminated in the disappointing Skyward Sword, which adhered so closely to this formula that it felt like a pale, paint-by-numbers parody of a Zelda game. Something had to change, and Aonuma knew it, saying, "We started to feel that fans may not continue playing this franchise unless they can think independently and try various things freely on their own, rather than following a set path." So it was time to mix things up. For the next game, which, spoiler alert, would be Breath of the Wild, he gave his team a wildly ambitious mandate to rethink every aspect of the Zelda franchise, to consider every convention that had become an essential staple of the series and ask if it truly had to be that way. Ayanuma says, "I told the staff, this time let's build the game without shying away from anything. Let's stop thinking about what Zelda has been up until now." Of course,
that's really cool. That's a really good way of putting it.
Of course, the first ideas were pretty out there. Link fighting aliens in UFOs, or dodging missile attacks from the sky, or meeting Lovecraftian monsters, or bombing around Hyrule on a motorbike. That was all a bit off. Well, except for the motorbike. But eventually the team came to look at the more fundamental, structural bones of the Zelda formula. That's ultimately what needed changing. The game's director, Hidemaru Fujibayashi, said, "We wrote down all of the stress points, the things that make Zelda games less enjoyable, and we replaced them with new ideas." And this led to 5 key changes to the Zelda formula. So, as stated, Zelda was a series where you must do things in a strictly linear and predetermined order. But for this new game, there would be no predetermined order. The 4 divine beasts and the 120-odd shrines could be tackled in literally any order you see fit. Or not at all, actually. The only mandatory bits in Breath of the Wild are the tutorial and the fight against Ganon. The rest is entirely optional. Now, this idea was trialled in A Link Between Worlds on 3DS, and it was part of the very first Zelda game on NES, but with Breath of the Wild, Zelda would finally see true freedom and complete non-linearity. But it wasn't just about linearity. Zelda was also a series made up of individual areas connected by doors, gates, and gaps in the clouds. But for Breath of the Wild, the world would be a single, contiguous space that can be explored in any direction. And nothing can block your path, as Link can swim across rivers, climb up virtually any vertical surface, and soar over the landscape with a paraglider. Zelda was also a series that told you where to go and what to do, often with an overbearing companion character who would offer helpful hints and advice. Breath of the Wild would be the opposite. Outside of quest markers that showed the location of the 4 divine beasts, players would be left to explore by themselves, and the developers would stay silent, choosing to guide the player through the design of the environment, or the placement of harder enemies, or with a breadcrumb trail of curiosities that lead you to the next important place. Zelda was also a game with handcrafted puzzles that would require you to find the designer's single intended solution. But for Breath of the Wild, that would be totally reversed. Instead, the world is constructed from a set of interconnected physical and chemical properties like wind, fire, electricity, and gravity. And so players could exploit these relationships to discover their own way to solve puzzles, defeat enemies, and bypass obstacles, even if that means skipping the puzzle entirely. Fujibayashi says, "I really want players to relish those moments where you do something and think, oh my gosh, I'm a genius."
That's really cool. Honestly. Yeah. I've never played this game, but I've it's making it out to be really exciting, to be honest.
And Zelda was a game with a pretty limited moveset and mostly contextual actions, down to having an automated jump when Link runs off the edge of a platform. But in Breath of the Wild, Link would have a surprisingly extensive moveset. That includes a dedicated jump button, the ability to throw weapons, climb up walls, surf on his shield, and more. This would give players way more control over Link's actions and let them travel through the world in a more freeform manner. And look, there are even more ways that Breath of the Wild mixed things up, like how you no longer get hearts from chopping down grass, but from hunting and cooking, or how Link now wears a blue tunic rather than a green one. But it was those 5 key changes to the Zelda formula: a non-linear structure, a fully open world, laid-back hints, systems-driven problem solving and an expanded moveset that really made Breath of the Wild feel so different. But here's the thing. The result wasn't just a fun game and a Game of the Year winner. The result was actually a fundamental shift in how the game relates to the player. You see, Fujibayashi refers to the previous Zelda games, like Skyward Sword, as passive games. Games where players go through the content in a predetermined order, solve puzzles by finding the developer's intended solution, and play within the tight confines of walls and obstacles. Games where the player merely follows the designer's lead in a docile, passive way. But with these changes, Breath of the Wild became the opposite of a passive game, an active game. Here, the player is very much in the driving seat. They choose what content to engage with and what order to do it. They choose where to go and how to get there. They figure out their own solutions to problems, and they have to think, plan, explore, and experiment in a much more active way. In a passive game, the designer's job is to make handcrafted content for players to experience. But in an active game, the designer's job is to make a sandbox, give the player some toys, define a goal, and just let the player get on with it. And I think this is quite an interesting lens through which to look at game design, as you can plot almost every game on this spectrum. From very passive games, linear, story-based games like Call of Duty and The Last of Us, to super active games, playful sandbox sims like Minecraft and Factorio, as well as everything in between. Now, in order to get here, the developers had to rethink everything. Art director Satoru Takizawa said to create an appealing, never-before-seen world filled with new surprises, you need to break conventions. You need to be...
I feel like with the active and passive, that can just be linear versus non-linear, right? I don't know. I don't think it's like a new concept.
Creatively reckless. But there were some other important factors too, like having fresh eyes. Aonuma gives credit to the contributions of younger staff members who would come up with fresh ideas and weren't set in their ways from decades of working on the same franchise. Fan feedback was important too. The producer says that Breath of the Wild's open world was made partly in response to players wanting to explore the areas in between the disconnected chunks of Skyward Sword. And there were also outside influences. The team played games like Minecraft, Terraria, and Skyrim to get ideas. Historically, it's rare for Nintendo to name-check other games, especially ones made outside of Japan. But whatever the case, the result was a truly incredible game. And for the Zelda team, it would prove impossible to ever go back to that more passive style of game design. Seriously, Aonuma was practically radicalized by what he saw in Breath of the Wild. It fundamentally changed his mind about how Zelda games should be designed. For instance, he said that he once thought it was a sin to let players get lost in a game, hence the overbearing helper characters and the linear level design of the older Zelda entries. But with Breath of the Wild, he saw how it could be fun to let players wander off the beaten track and find their own adventure. He says, I wanted to basically have the players experience this getting lost while getting to the next destination because this journey leads to something they've created with a path they've chosen. I myself learned that getting lost wasn't so bad after all, so I was able to reflect this idea to this game. So for Aonuma, Breath of the Wild showed a new and, to him, much better way to design games. In fact, when he replayed The Wind Waker, he thought it felt outdated. He's described set puzzles with single solutions as being an old design. And as for future Zelda titles, well, he says, I think for me, the incredible freedom that this game offers you and how well that's been received, to me it means that level of freedom is something that needs to be maintained in Zelda games going forward. My eyes have been opened to how important that is. And so Breath of the Wild has continued to influence future games in the franchise, and the sequel, Tears of the Kingdom, doubled down on this active, player-led, problem-solving gameplay. In fact, Nintendo was so inspired by how players used the Breath of the Wild sandbox to pull off wild and unexpected things that the sequel gives you even more radical toys, including the ability to glue physics objects together to build vehicles and machines. And players are given even more opportunities to exploit the game and find their own solution. Take the ability Ascend, which lets you dig through the ceiling and pop out on the other side. It started as a debug option during development to let the creators quickly skip past content, but it later became a de facto power in-game. Technical director Takahiro Dota said, "We've placed more importance on creating a game that enables players to do exactly what they think they can do, rather than how we want them to play the game." And then there's the spin-off title Echoes of Wisdom, which was made by outside studio Grezzo. The team pitched a clever copy-and-paste game mechanic, and Aonuma was like, "Yeah, cool, whatever, great, just make sure the player has tons of freedom." So the game lets players be mischievous and exploit all sorts of cheesy tricks to solve problems. And players are allowed to tackle challenges out of order and are encouraged to find their own path through the story. Co-director Tomomi Sano says, "We put effort into maintaining player freedom. Limiting mechanics makes development easier, but it frustrates players when things don't work as expected. We wanted to avoid."
You know what's funny? I feel like watching this video, it's like game developers rediscover that immersive sim games are good. You know, after they got abandoned.
That. So, if you ask Aonuma, this is how every Zelda game will be going forward. He says, "Games where you need to follow a specific set of steps or complete tasks in a very set order are kind of the games of the past. The games of today are ones in which that can accept a player's own decisions and give them the freedom to flexibly proceed through the game, and the game will allow for that." In fact, he went so far as to question why anyone would want a game that felt like the older Zelda titles. He said, "Why do you want to go back to a type of game where you're more limited or more restricted in the types of things or ways you can play?" And, well, sir, if you're asking, then I have some thoughts. Because here's the thing, as much as I love these 3 new games and all of the advantages that this active design philosophy brings, I have to admit that these games don't always feel like Zelda titles. And that's because some of the changes necessary to make an active game ended up removing some of the stuff that makes Zelda, well, Zelda. For example, consider that old formula where you get a new item in each dungeon. This might be linear and restrictive, but it does mean that each Zelda game has a wonderful sense of mechanical.
That's right, math time indeed. Just about to finish my lunch and we'll get right back to it. Watching a video on game design at the moment. Yeah, thank you for joining us, by the way.
Cool progression, where you get brand new toys at fairly even points throughout the adventure. As the game goes on, Link becomes more powerful and adept, and the player is always left wondering what cool new ability is just around the corner. But for Breath of the Wild, well, the team never wants you to reach a shrine or a dungeon that requires some ability that you don't have, and so the solution is to just dump all of the game's mechanics on you during the tutorial. Which means you'll see pretty much everything the game has to offer in the first couple hours. And then only one of the dungeon's rewards, Rivali's Gale, adds a fun new wrinkle to Link's moveset. Then there are the dungeons themselves. Zelda's old temples are beautiful puzzle box playgrounds. Clever, spatial reasoning conundrums that you slowly unpick by finding keys and items, or by changing the water level, moving back and forth in time, or flipping the entire temple on its head. But that sort of level design requires heavy restrictions, a narrow lock and key structure, and handcrafted puzzle solutions. That doesn't gel with Breath of the Wild's freewheeling movement system and puzzle design, but that leads to lax dungeon layouts that can be cheated and cheesed. And so the new dungeons often end up feeling messy and, frankly, unsatisfying. I didn't even bother doing a Boss Keys episode on Tears of the Kingdom's dungeons because what's the point if you can just phase through the floor and skip half the puzzles? And More broadly, Nintendo's focus on player-driven solutions can sometimes lead to moments of surprise and delight, but just as often it can lead to repetitive solutions, cheesy exploits, and outright cheats. There's also the storyline. I've never been too fussed by the narratives in Zelda games, but they do at least have a structure. Breath of the Wild's plot, meanwhile, is essentially a bunch of disparate memories told in a jumbled up order. There's no emotional escalation, no dramatic timing, no pace, no structure, no arcs. And finally, the older Zelda games were full of beautiful, curated and handcrafted spaces that have resonated for decades. But the new Zelda worlds, by dint of needing to be utterly massive, can feel empty, soulless, and repetitive. These worlds even veer into the realm of feeling like they were generated by an algorithm. So when Ayanuma asks why anyone would want to return to the older style of Zelda, well, this is why. There are hugely important aspects of those older titles that have simply been lost in the shuffle. And ultimately, I'd argue that the active design philosophy of Breath of the Wild isn't inherently better than the passive design philosophy of Ocarina of Time, it's just different. In fact, both styles have their own pros and their own cons. They offer different experiences that suit different players, or just different moods. Sometimes I want to go on my own adventure.
Yeah, sometimes linear games are just good. I think that's the that's the thing here, right? Linear games are sometimes good. Non-linear games are sometimes good. Isn't really. It's not like you need a one is better than the other, but I do. Skyward Sword, at least, is probably a bad example of a linear game. I don't know. Some of the points he's making are valid, but I don't really have any emotional attachment to older Zelda games, so it is what it is to me. I don't really care either way, which way it goes. Shall we generalize to content? Oh, to reacting to content. I'm just gonna eat. I'm just eating right now. I just can't type while I'm eating. But yeah, I just thought it was just like an interesting point of view. Maybe not. Maybe basic. I don't know. Yeah, but I'll get back to maths very shortly. I'm almost done.
Across an uncharted landscape, but sometimes I just want to be delighted by a developer's carefully curated experience. But here's the question. Does it have to be one way or the other? Because in the last year, I've played 2 games that had me thinking about how Zelda might reconcile its 2 different eras. The first is Resident Evil Requiem. No spoilers, don't worry. So this game cleverly mashes up 2 very different parts of the franchise's history. When you play as Grace Ashcroft, the game is a first-person haunted house spook 'em up a la Resident Evil 7 and 8. But when you play as Leon Kennedy, the game turns into a campy, third-person, action-packed romp calling back to Resident Evil 4, 5 and 6. This two-hander not only satisfies fans of both styles of game, but it works as a nifty little palate cleanser. Just when your anxiety is amped up to breaking point, the perspective shifts.
Go for it, man. Now, get your lunch. I'll be here for you. Hopefully you enjoy your lunch, whatever you end up eating. Yeah, I'm just like almost done.
To Leon, and you get to blow off some steam. Could you do something similar for Zelda, a game that incorporates aspects of both eras? Maybe. I could imagine some future game that more clearly delineates between the overworld, which would play like Breath of the Wild, and the dungeons, which would feel more like classic Zelda. And as for the other game, well, it's no secret that Breath of the Wild has inspired other Nintendo franchises beyond just Zelda itself. Fans and critics have noticed its influence on games like Mario Odyssey, Bowser's Fury, Mario Kart World, and of course Pokémon Legends. Plus, Metroid producer Kensuke Tanabe has specifically said that Breath of the Wild's open world design led to the inclusion of the Desert Hub in Prime 4. But then there's the most breath-pilled game of the bunch, Donkey Kong Bonanza. Like, these are totally just shrines, right? Now this is a very active game. This is a game where you don't just climb up and over any surface, but can actively smash right through it. It's a game with an ultra-expansive moveset. It's got heaps of optional content. Did you know you can complete this whole game without ever picking up a single Bonandium gem? And there's a lot of freedom in how you go through the game. Co-director Kazuya Takahashi says there's a lot of leeway in terms of progression in this game. For example, locations or parts of the story you can skip without suffering any consequences. Typically, in game development, restrictions are put in place to prevent sequence breaks from happening, but since this game is all about destruction, we wanted people to play freely. But it's not total freedom. The animal transformations are doled out across the entire adventure, just like classic Zelda items. And there's a storyline with an actual plot and like stuff that happens. I know, crazy, right? Now, I don't think Zelda has to copy Bonanza's structure entirely, but it just goes to show that it's possible to balance player-driven freedom with designer-set progression, a mix of active and passive elements. So, look, we don't know much about what Nintendo has planned for the next Zelda game. We've got some clues. We know it won't be a direct sequel to Tears of the Kingdom. That would be a sequel to a sequel, which is getting a bit wild, says Ayanuma. And it won't feature Ultra Hand. That's a one-off mechanic exclusively for Tears. Oh, and it may take some inspiration from that new Hyrule Warriors game, but it's very vague what that might mean. And also, I haven't played that game. Is it any good? I don't know. Let me know. But here's what we do know. Just like how the previous games worked off the formula set by Ocarina of Time, this next game will build upon the template set by Breath of the Wild. But I don't think we've seen the final form of this new style yet, and I'm confident that we'll see Ayanuma and his team tweak and experiment with this new design philosophy, inspired by both fan feedback and competing games.
Okay.
And if we're lucky, they'll find some mythical middle ground, halfway between the imaginative, free-form, experimental fun of Breath of the Wild and the beautifully handcrafted majesty of Ocarina of Time. To be honest, I just don't know, but I'm looking forward to seeing what they come up with. Happy 40th anniversary.
Maybe this video is a bit lost on me, but I don't think either are bad or good. I just think it's... I don't know. Maybe it's a bit not bad or anything. Game Maker's Toolkit here, I think was feeling nostalgic for a time when Zelda was different, and he isn't necessarily. This is what the vibe I got from this video. There's an undercurrent of he's missing what it used to be like because it's different, and the criticisms weren't the fact that it was worse in those ways. It was just not what his childhood once was. I'm sure this. I think Game Maker's Toolkit is a very big Zelda fan. I think when things change in your favorite franchise, like quite dramatically, it can be quite upsetting. I guess I don't know. But yeah, that's how I felt about that. Anyways, let's do some maths. We are back from the black. All right, let me just adjust the audio again as well because I don't want to blast your ears off with something really loud. I think that's roughly where it was. Let's just see. Play some music. Let me just check. That seems good for you guys. Like maybe a bit louder. There we go. All right. Let's bring up our book. And let's go through the normal matrix calculation stuff. Yeah, I think if it's a really complicated latex, thing that I have to type off, I'm not going to bother. Because this is just getting out of hand, where I'm like having to type subscript, superscript, vec, over and over again. It's just not practical. But effectively, all this is doing is building up a matrix, multiplying it by an array, a vector, and then each thing becomes vector B and vector in the new coordinate space, which is, you know, based on this definition up here, which is basically what we're doing. So I'm just gonna write that down actually, because that's gonna be useful for my future self. We are just creating a matrix that transforms. All right. Oops. No, not too many. Vec v underscore, and then because we're not doing that, a to b, and this happens sorry, based on the definition we defined above. Not above. Cool. Okay, so each entry of the matrix multiplication of component VA by a ratio of an axis-aligned distance and the axis appearing. So yes, for those who have joined us just before, we are I'm just going to read this out loud. Okay, so the axis aligned appearing in the denominator of the ratio corresponds to the components of VA by which the ratio is multiplied. Yes, this effect cancelling the distance in the coordinate system A, replacing them with. Okay, yeah, sure. So Dimitri has said, but you still have old games. If it's not the right vibe, you can create your own with the right one. Yeah, it's a good point. Yeah, a lot of people made their own games because their vibe, you know, they want a puzzle game. So that is a really good point, because I think Game Maker's Toolkit made a game himself that was like a puzzle platformer, which felt, now I think about it, felt very similar to like older Zelda games, where everything is just, because he must appreciate the puzzly, platformy type things that he have to solve in the older Zelda games. Yeah, so yeah, you're not wrong there. Now let us consider a. Yeah, and I encourage anyone who's watching this who does have an idea that they want to do, yeah, put it out there. Put it out there. If you feel the same way about your favorite video game franchise, that it could be different in a particular way, you're probably right, and you probably would be worth making. Anyway, now let us consider a normal vector that was calculated as a gradient. The key understanding how such normal vectors transform is realized when realizing that the components of a gradient do not measure distance along a coordinate axis, but instead measure the reciprocal distance. I see. Okay, so let's see here. Okay, so if I say, if we consider a normal vector, we calculate things as a gradient, apparently. Gradients. The key understanding how such normal vectors transform is realizing that component of a gradient do not measure Is this just like a physics thing that a gradient of a slope doesn't measure distance, is the inverse of the distance? So if I take the distance and then we do the reciprocal, I get the gradient of the distance traveled. I don't know. I think it's, so Dimitri said, I think it's more correct this way because Vibe isn't covered by copyright. Yeah, 100%. Yeah, do things based on that. 100%. I agree. Don't just copy, as you can escape copyright that way. Anyway, do not measure distance, but the reciprocal. Distance, which is interesting. Alright, I'll bold that. In partial derivatives that compose a vector of all those, I'm not going to say them out loud, the distance along x, y, and z appears in the denominator. I see. Okay. This is because if you consider the partial derivatives, that compose a normal vector, when you consider a point on a surface. So I will take this out because this is not that difficult to write. So delta f divided by delta x. So that should be good for the rest. Z and Y. Y. Okay. The distance X, Y, Z are all in the reciprocal denominator. What am I saying? Denominator of the vector. This foundational difference from the measurement made by the components of the ordinary vector sorry, let me read that again. This foundational difference from the measurements made by components of an ordinary vector and its source of the problem exemplifies by a non-uniform scale shown in 3.4, whereas an ordinary vector is treated as a column vector with vx, v out, v, and all the v's written as we write a normal vector n as a row. Okay, so its source. Right, it's 3.4. I think that was this, right? Yep. 3.4. Whereas an ordinary vector, V is treated as a column matrix. We write... okay. Because of the... normal matrix, vector, as a row matrix rather than a column matrix. for a normal, sorry, for a regular vector. Okay, so, so since this is so different, we write them as, okay, that's fine. Oh, cool. Now I get why we do a normal equals transpose inverse. Ah, yes. By the way, that isn't the meta anymore. Satvik. I think it's in this book. It will explain, but you really want to do an adjunct matrix of the model matrix. This is the real meta now. I can send you a resource if you're interested. It's actually, I think Ratchet posted it in the Discord. If I okay, nothing's crazy going on in the Discord. I think it's this. Yeah, I highly recommend looking at this. This is, yes, when we're calculating the normal matrix. I'll just look at this real quick, but yes, we are calculating the normal matrix here. But there's like 3 adjunct, transpose inverse, correct, sometimes incorrect and slow, and then just using the model matrix, which obviously we just worked out is wrong. Yeah, so yeah, and this is the adjunct matrix. You can see in the camera, but I think if you do look at, it's a very hard difference to tell. But if I change this, you do see some errors right at the peak of the shadows. It's hard to see, like, but anyway, if you see it in number 2, I think it's obviously a better version. Oops. If you see 2, it's like obviously wrong. It's got like weird artifacting, but I think as far as I could tell when I squinted and tilted my head when I was staring at this, there is still some of that left over somewhere whenever it hits a particular rotation. Either way, it's slower anyway, so yeah, adjunct matrix is the one. Yes, I don't know why the OpenGL tutorials got this not wrong, but well, it is sometimes wrong technically, mathematically, but I don't know. Anyway, but yeah, that's the key. Okay, yeah, no problem. Yeah, but that's in the if you look at the resources, that'll be this resource right there. If you want to actually pour over this, but we're actually going to go through this ourselves anyway, mathematically speaking. And it's good as well because it is faster, so it's like a win-win, more correct and faster. Right, so I'll close that for now because that'll eat some RAM. Okay. Right, I can write this out later because it's relatively easy. Oh, I love this song so much. If I could, I would get away with playing this for like a couple of hours. But alas, that would make a terrible listening experience for everyone involved, other than me. Yeah, it becomes apparent that multiplying this vector on the right by a matrix in the equation 3.6 has the effect of cancelling the reciprocal distance in the coordinate system B and replacing them with a reciprocal distance in coordinate A. Cancelling the M matrix, we can state that it simultaneously transforms the transform that takes ordinary vectors ordinary vectors from B to A through the product of VBMA and the transform that takes normal vectors in the opposite direction from B to A, say A to B, sorry, A to B and then B to A, through the product is, yes, this. Inverting the matrix, both of these, inverting the matrix reverses both of these transforms, so we can conclude that the correct transformation from A to B for normal vector at least one calculated from at least one calculated using the gradient is given by this. Okay, so since I don't really, okay, so I think it's just what we need a matrix that can when inverted can reverse the transformation. I'm lost in constructor. Oh yeah, constructors are a bit tricky, considering there's like lots of different versions of constructors. Yeah, so that's actually quite a difficult topic, but it is quite important because it can lead to undefined behavior if you don't know how it works. So it is worth studying when it comes to C++ anyway. Normal vector from one transform back to another. I think that's literally all that said. Yeah, they are a bit strange syntactically. You'll get there, dude. Well, fortunately for you, destructors are actually simpler. Equally as important, but simpler. Syntaxically, anyway. So you should be able to like carry your knowledge that you've worked on. You know what you've done. Anyway, so the correctness of equation 3.8 can be verified by demonstrating that a transformed normal matrix remains perpendicular to the transformed tangent vectors. Suppose that NA and AT are normal and are tangent to the surface at a point coordinate at a point in coordinate space A. By definition, they are perpendicular, and they must have dot product of 0. Since NA is a row vector and TA is a column vector, the matrix the matrix product AT is actually what's being calculated here, but the dot product is still included by convention, even though the notation is technically not correct. To make it clear, we are producing a scalar product. Yes. Okay, so fair enough. We also need to be able to take the syntax. Yeah, lots of stuff in code. In Destructor, you just use the delete operator. It is simple. Inheritance makes that a little harder. But yeah, there's like rules with destructors that you don't want to that you need to be careful of. One of them being if you return early in a destructor. So for example, let's just say an exception gets thrown inside a destructor. And you think, okay, I've sorted out, something happened in the destructor, we need to fix it, and it throws out some random piece of code, that object is still going to get destroyed, but it's not going to finish its destruction code. So you need to be careful with that. There's stuff like that, yeah. Yeah, and virtual destructors. That's the second thing I was about to mention. So there's like destructors are a little tricky. They have their own like little rules that trip you up. And you can see this actually. It's I think it's ED in Visual Studios. Something that needs to be deleted. So Visual Studios has like address codes that can happen. So like for example, CD. Nope, that's not CD. CD is uninitialized data. This only happens in debug mode, by the way. And I believe it's EF. If something's marked for deletion but hasn't been deleted, it's EF. And you can end up with an object with that that memory address, EF, if you return early from a destructor, and you haven't handled you haven't handled things properly, where it's like marked for destruction but hasn't actually been deleted. It's very awkward sometimes if you get destructors mixed up. Sorry, if you mess up a destructor, they can end up all kind of like weird. You can end up in like a really awkward situation, and it's sometimes hard to fix. Yeah, so I could be wrong with that EF, but I think I'm right. The Visual Studios has like a bunch of stuff that gets initialized at default. That's all to say that that I'm just trying to motivate you in the sense that yes, it's difficult what you're learning, but it's actually like, super worthwhile, because this stuff trips up people a lot and they don't realize what's going on, and it can be really aggravating when you're like in the middle of a project and then you don't understand why things have gone wrong and you realize you've put early returns in your destructor, which you can do if you handle that correctly. It's fine, but you've got to know, like, you've got to be careful what's going on. The general rule of thumb is do not put an exception. Do not throw exceptions in destructors. Unless you're very, very careful what you're doing. Feel free to throw them in constructors though. They're free for the taking. But destructors, on the other hand, that's harder. When do you not handle correctly? Memory leaks happen. That can happen. You get undefined behavior effectively. You don't just get a memory leak. You get a thing that's marked for deletion that still exists. So it's you can kind of get like bad allocation, like bad access read access violations, and undefined behavior in the sense, let's just say you had a vector of objects and you did this early return in a destructor, and then you iterate over these objects or something like that, right? Like, what's going to happen when you access this to be deleted thing? Okay, so Dimitri has said if Clang Tidy has a receipt for this case. A recipe, sorry. Yeah, anyway, so you can at least test the source code for this error. Yeah, some things will throw this up and say, "What are you doing? This is not a good idea." It's doable, but it's you got to be careful. I don't even want to talk about and Dimitri's also said if anything, it's Clang Tidy. Yeah, it's sorry to. When I say I don't want to talk about this, it's kind of more funny than anything. I worked at a job and someone was returning all the time early into destructors. This was to stop Qt, which is a GUI library, right, from destroying the object internally. Instead of working around Qt, they just kind of hacked in an early return and then deleted it later. So this object was just like floating around. It was like it ran, but it was like only on the application shutdown were we allowed to destroy these things that were returned early in the destructor because of some convoluted code that was the worst I've ever seen, where the main window was an object and the object was also used within the main window. So we had like multiple main windows within a main window, and we couldn't delete these objects because it would close everything. So we had to like do an early return because we didn't want QT we didn't want QT to clean up the object because, like I said, it'll close the window. So it was a mess, bro. Trust me, you don't want to put early returns in destructors because something's gone wrong if you've done that. Something's gone very wrong. In my opinion, right? I'm sure there is a use case. I'm sure it exists for a reason, but most of the time, here be dragons. Stay away, stay away, stay away. Yeah, it was one of the most confusing parts of the code base. And there was multiple... I want to say most confusing. It was like, there's a group of confusing parts, and that was one of them. There was more confusing parts. I will spend a lot of time in C++ fundamentals. Fantastic, dude. You're going to be a great C++ developer, I tell you. You're not going to make those mistakes. So it's definitely worth learning all this stuff because it'll avoid those mistakes, which only turn up later. So it's important to know that type of stuff. Anyway, we also need to take... We also need to be able to do a... and... Oh. If... Oh no, these aren't vectors. That's a... Well, I don't know what to call this. I'm going to say non-n. No, I've already started to call it vec. Yeah, anyway. Which is a column x row matrix multiplication. Oops, multiplication. Which is often incorrectly referred to as a dot product. Cool. Strawstrup says you will code professionally. Yes, that's good. It's better to test the linter right away. Highlighters are good for identifying errors and poor style. Yeah, that makes sense. That's what Dimitri said. If you only see Russian. Yeah. I don't need linters really, because my code is so basic. I barely use destructors and constructors, honestly. Apart from the default ones. And I obviously do the design pattern properly if I'm doing a singleton. But maybe I should. Maybe actually, I say that I shouldn't use. I don't need linters. I probably do. But anyway, it's not the end of the world if you don't use them. But yes, it will catch those type of mistakes. Yeah. Anyway, let M be a matrix that transforms ordinary vectors from coordinate space A to coordinate space B. Then a transformed NB is given by inverse M, and transformed tangent vectors is given by this. We get this product. Okay. So here's the... And this establishes the fact that they are perpendicular coordinate systems from A to B. Okay, so this is the old method. This isn't used as much. Apparently, it's sometimes not correct. I would need to look at that again. Okay, so this all comes down to this. If we have matrix A, oops, A, oh sorry, coordinate system. System A, and so we have, so it comes to this. If we have a matrix that moves things, say vectors, I guess, vectors to coordinate space A to B, then say n n B is given by n underscore A, no, subscript, superscript even, A M, and again it's the hopefully I can just do to the power of -1. Hang on, can I just write this as this? This might be like super easy to write instead of what I'm doing already. Yeah, okay. Okay, that makes my life light. And transformed, so this is not the meta anymore, but whatever, I'll finish it off. T to the power of A. Sorry, I'm just writing this out concentration style. Gives us there's no identity when you do this. Gives the product. This is useful to know because we'll be able to manipulate tangents and normals better. So, you know what? I'm gonna yeah. Right, so TB, there we go, and equals n to the power of t times by m to the power of -1, so it's inverted, our invert matrix, m t to the power of a equals to n to the power of a c dot t to the power of a equals that. So it all kind of resolves to itself. Oops. So I delete that. Oh dear. Excuse me 1 minute. All of a sudden I'm sneezing. Oh, that hurt my throat. Oh. Give me a sec. Oh, dude. Need to recover. Let's get some water. Oakley dokley, let's get back into this. Fantastic mathematics. Anyway, give the product. This established the fact that they are perpendicular. Okay. And this means that they are still perpendicular. T and N are still perpendicular in coordinate system B after the transform of M. Alright, so yep. One thing this book makes extremely clear, which I really like, is that when you I think I'm going to leave that together. When you multiply something by a matrix, you're moving. Thank you for the blessing. You're moving from one coordinate space to another, and I think it's really insightful. Anyways, insightful in the sense that it's like that's literally what you're doing. All right, so I'm not entirely sure if I need to do literally all this. I think the important part is this, because that is the adjunct matrix. So yeah, we'll see if we actually need to copy all this. So maybe I'm going to type in adjunct. Am I saying that right? That's what I've been calling it. Maybe hang on. I might have learned this word wrong many years ago and never corrected myself. Educate maybe. How do you say? I hate when it doesn't come up with the thing. Yeah, just bear with me just one moment. Educate. It's just educate, not whatever I was saying before. Adjunct, educate. Sorry, educate matrix. Educate matrix. I've been saying it wrong. I apologize. Educate matrix. Yeah, I just realized the educates normal matrix. So I'm just gonna head to the loo real quick and remember it's educate, which shall be good. So we'll continue on with this, and we'll be able to crush it as we continue onwards. Right, let's pause this, and I will make a quick BRB. You know, because I'm a professional streamer, which is, you know, look at this. Look at that. Streamer professional quality BRB screen. Okay, I regret doing that. What have I done? It's the first time I've ever clicked that button. I thought it would do like a little quick ad while I'm at the loo, but I guess it didn't do that at all. Now we got a 10-minute countdown to whatever it's gonna do. Well, you never know. Hopefully it's not too obstructive. I apologize. Dude, I don't know what I'm doing. Whoops. Anyway, what I'm talking about is I clicked this ad button that's kind of appeared recently on the live stream. I was thinking, oh, it's just like a quick, 1-minute ad or something. While I head to the loo. Because you're not missing anything. So now I've got to, like, be aware that that countdown exists. And maybe wait for it to, go away. Because I assumed it would be better. I was trying to make it so that you don't get adverts when I'm actually trying to code. I was like, all right, yeah. So let's put one in. Now I've just put one in 10 minutes, which is completely useless. Trying to make it a bit more. Oh, whatever. Trying to put the adverts in the right place. And never mind. Okay. So, okay. Getting back to the example, in figure 3.4. A transformation matrix M. Matrix M is, excuse me. Another sneeze, flipping heck. Getting back to the example in figure 3.4, the transformation matrix is this. Yes, makes sense. When we align the x-axis with a horizontal direction and y, and with the vertical direction, we can take the normal vector before the transformation to be a 0. Yeah, sure. Transforming this equation gives us a new vector normal of half BA, which is perpendicular to the transformed surface. This important observation to make this important observation is to make that this is an important observation to make that the matrix M scales x values by a factor of 2 because the normal vectors use a reciprocal coordinates as shown in equation 3.7. Yes, multiplying nx by 2 is the equivalent of multiplying the x component of n by a factor of 1/2, which is exactly what inverse M does. Cool. Yeah, makes sense. Yeah, okay. So since we are aware that the gradient the normal vector stores the gradient of the distance and not the distance to scale the matrix by we need to treat treat the normal vector like a 1-column row vector described in. So I'm just going to link to a note that doesn't exist. Building a no. I'm going to call this the reasoning handling normal vectors when transformed. Okay, so Okay. Is that gonna... Very nice. Thank you. Bit of maths today. Hope you're up for it. Thank you for joining us, Proven. Okay, so column, row, one column row matrix. Sorry. So. Okay, so the reciprocal coordinates are shown in 3.7 multiplying. Okay. Yep. Okay, so to do this, we can just invert the... Ah, you a simple duck. Okay. I proven up. Hello. It's been a while. I'll show you what we're up to if you want. We still have the duck. But now we have a menu. And obviously exit exits the game. Start starts the game, which I'll restart. And yeah, we've improved the lighting. Since you were last here, we still have a lovely duck. We have a directional light, and we have a point light, which lights up the object as you get closer. We are testing deleting things, which took a while. We had to come up with a whole new system for it. But yeah, this is what we're up to. Yeah, still gotta like it. So if I go near this rock over here, you can see it lighting up more and more and more. And you can do something like whoa, or shoot it or something. Ah, thank you. I love melons. A duck in space. I know. I love it as well. If we can find the other ones, there's more over there. I'm definitely going to sneak some rubber ducks into the game, because obviously this is going to be a spaceship eventually, but it's just a convenient object. So you know, if you guys end up playing it, let's see if you can spot them. How long to get on your level? We had this discussion earlier on in the stream. It will be a duck shooter this time. Yeah, 100%. It's an interesting question. Let me just pause for a minute. My time. Oh no, I've already paused. Okay, so how to get on my level? It's an interesting question because you've got to really understand proof an object. Like how would you get to that level? One, you've got to recognize that I don't really feel like I'm at the level of an expert even. So that's something, you know, but also knowing where you're at and you know, working on your skills relative, that because it's taken me years to get to this point, right? So it might take you years, or it might take you a week. I don't know. You know what I mean? Or you might already be past me. I actually don't know. Like where you are relative to me and how much that requires of study if you've like just started programming yesterday. I do have a very crude roadmap, but at the end of the day it requires one thing, and there's only one thing that's going to get you good, and that's just practice. And if I open up this video, you'll see what I'm talking about. So if I go to my resources, yeah, so the key to it all, that the biggest hack is, if I pause that for right, pause that for a minute. You know, I like this video a lot. I've recently found out about it, but here's the keys to the castle, guys, if you're interested.
Got practice.
Let me start again.
Got practice.
Yes, it is.
Practice, 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 practice. Practice. And if you haven't practiced, you should be practicing. So keep practicing. It's the only way you're gonna get better. It's the only way you're gonna be number one. Number one in anything. You need practice, practice, practice.
Yeah, there you go. That's the secret, guys. Thank you so much. I'm a third year student. I understood. Practice, practice, practice. Thank you for the reactions as well, guys. In the stream. Hearts to you as well. Let me just adjust the audio so you get your ears blasted off. Let me listen to music. yeah, so that's what I'm doing. I'm just practicing too. I'm just practicing like everyone else needs to and should. Share that video, bro. I've got it. Yeah. The practice one, of course. It's so good, isn't it? It's got that old school vibe of like early 2000s swag. You know what I'm saying? It's so good. It's a nice one to come back to. Yeah, I'll throw it in the chat for you. There you go. Oops, nope, that's not what it is. That is I didn't manage to copy. So copy, please. Thank you. And paste. There we go. Yeah, share in chat. There you go, dude. No problem at all. All right. So yes, let's get back to practice. It's the only way to get good. And you never know, you might overtake me and I might be asking you for advice in the future. Who knows? Right, so close this. Let's bring up my book again, which is... Yes, this one. Where is my notes? There they are. Thanks, man. No problem. I just got 2 eyes. Oh, I apologize. Okay. Yeah, I pressed the add button. I didn't know what it did. I apologize. I spent the second year of college doing C++ and OpenGL, now learning Vulkan. Good luck. You see, yeah, that's it. It just takes practice, bro. Yeah, I didn't know what it did. Because I'm very new to... I just got my channel like monetized, so I don't really know what's going on. So I'm getting like less than $1 a stream. False ongoing. Oh my goodness! I wonder if I can turn it off. No, I don't know. I don't know how. Okay, let's play some music. Why Windows? Most gamers are still on Windows. I have to use that as my main development platform. This will run on Linux. Don't worry. I don't. But for now, we're just on Linux. Sorry, Windows. But that's about it. Oh, it's the practice video. It's getting 1,000 adverts on iPod. I had no idea. Dude, that's really weird. I hope you work for RDR3 and make a great game. RDR3? But thank you. Yes, I hopefully make I hope I will make a great game. Congrats on the $1. It's actually less than $1, but you know that's a whole it's all get the fish. No, I'm using why Vulkan instead of OpenGL. Oh, just because I want to it's like the future, so I want to keep up with what's going on in the future, and yeah, that's generally what I'm trying to do. OpenGL is definitely still supported. It will be for decades, I think, even, but some stuff that is not being supported and newer stuff isn't coming to OpenGL. So yes, I thought I would be stay with the future now. So in the X amount of years in the future, whatever that may be, and I want to use some new feature that graphics cards can do. It'll be in Vulkan, but it won't be in OpenGL. So yeah, let's get back to the mathematics. All right. Yeah, thanks for the questions, guys, and thank you for joining us. It's honestly always a pleasure to see people. Yeah, all job descriptions I see require DirectX or Vulkan. Yeah, that's 100%. That is my mentality. What are my takes on AI? That's a big topic. I'll just say, when it comes to programming, I think it's oversold, in the sense that I don't think it's going to take programmers' jobs. I think the only people say that are salesmen, which includes the CEOs, by the way, of these companies. AI is cool in general. I like what's happened. I like the technology. I like what we can get computers to do. It's really interesting that we can converse with computers and they can understand to some very limited degree on what's correct when they need to speak back to us, which is kind of cool. But but I'm not a big fan of the companies themselves. They kind of cringe in a lot of ways. So yeah, that's my general idea of like that's my general like stige of AI. I think, and additionally, if you're learning programming, I would recommend to stay away from it because it will put a hard ceiling on your ability. But you know, that's just an opinion. You don't have to. You can use AI all you want. I'm not going to yell at you. Anyway, so to do this, we can invert the matrix. So yeah, that's hopefully that's a quick. That was a decent answer. But yes, to what about open source ones? Like GLab? I don't mind the tech. I think the tech's really interesting. Yeah. Thanks for the reactions as well. Yeah, I just don't use them, so I think they're interesting, and that's about it, really. Honestly, I just think they're a cool piece of tech that's a bit that's extremely overhyped. That's about it. You know, it doesn't matter if it's open source, closed source. Yeah, it is. Anyway, so in this case, so I'm going to read this book out loud. This is a book that you can find in the description. It's not free, but you know, if you do want to learn serious maths when it comes to game engine development, yes, this is a great, fantastic book for that. Okay, in this case, in the case that a normal matrix A is calculated as a cross product between S and T, between two tangent vectors S and T, the transformed matrix vector B should be equal to the cross product between the transformed tangent vectors. Again, let M be a matrix that transforms ordinary vectors from vectors from coordinate system A to coordinate system B. Then NB is so those matrix multiplied by S X cross product MT, but we need to be able to calculate NB without any knowledge of vectors of S and T. Expanding the matrix vector product by column with this equation in 1.28, we can write it as nice. Okay. I made YouTube Shorts generation using that model I spent $0 on. Yo, okay, cool. Hopefully it was fun. I'm asking what's the reaction to use Vulkan. It's 10 times longer to set up, so it's not a really stupid question. Yeah, it's not. It's a valid question. Like, I think people who are for example, it's a really valid question because it's if you want to, for example, make a game engine and you don't need the features of Vulkan, and you don't have a lot of time in your hands, maybe it makes sense to use OpenGL. It's a completely valid approach to approaching game engines. It's definitely not going to be as helpful in a job environment if you're trying to get a job as a graphics programmer, but you know, it depends on your goals and on what you need to do in your programming. So, yeah. So it's a really good question to ask, because if you can get away without coding something as an indie developer, that's a W. That's a win. And sometimes picking Vulkan over OpenGL is the smart choice because of that. So yeah, it's a good question. That's why I don't use a big complicated entity component system, for example, because I don't need it. And if I can get away with not using it, then that's a W. That's a win. So yeah, it's a valid question. It's a very valid question. Anyway, if we I don't mind answering these questions either, because it's it helps me make sure that I'm on the right track and not being what I call a busy idiot by making software that I don't need to writing software I don't need, right? It's like being a busy idiot. You're being productive in the wrong way. Anyway, if we have 2 vectors, yeah, because some people have in the chat been like, "Oh, why are you doing it like this?" And I have actually changed what I'm doing based on that, because I do like to listen to people's opinions. I don't always take them. You know, if someone says use OpenGL instead or whatever, I wouldn't necessarily be like, "Yeah, okay, I'm switching today." But yeah, you know, I do like to listen to you guys from time to time and seriously consider what you're saying. Anyway, which are 2 tangent vectors. We can take these and do a dot product cross product. And get a normal vector. Oh yeah, that's true, Emmanuel. I didn't think of that. About that, it's got no corporate shenanigans. Actually, I don't really. Yeah, it's I don't know. It's yeah, I guess they're better on the surface, but I think they would have corporate shenanigans if they were the ones that were leading the field. You know. But yeah. I don't, like I said, I'm not an AI researcher or an expert, so I don't really have good opinions on many AI things. Anyway, so the cross products, get a normal vector. We need to make sure that this holds true. Do we have a, yes, okay, so, oh, I remember now, okay. Right, so we need to grab something from earlier on in the book. I remember because this is a cross product cross product thing. So if I scroll up to the cross product, excuse me, there's like an identity with the cross product, which is kind of useful. I think it's before that. That's subtracting matrices. Yeah, let me just grab. Just currently doing this at the moment. Okay, so that's what I'm doing at the moment. Okay, so sign. Because I want to make a little game before I go back to the corporate world. So I'm just taking a little break from that at the moment because I kind of got a little bit burnt out by just doing a bit of maths. So yeah, here's the identities I'm looking for. So, what is it? We put all the components on one side of it, and we have like a way of solving this. Is it not? It's not here. Okay, maybe it's a matrix identity actually. Regardless, it's some kind of axiom. Oh, what am I working on right now? Let me, sorry, I didn't read the question properly. Yes, I am working on my maths, so just taking a little break. But yes, I don't know if you saw earlier. This is what we've got. Yes, this is the debug renderer running. I'm doing this because I want to be able to understand geometry better, so I can do more geometric calculations within shaders, right? So yeah, that's what I'm doing. I know you saw this earlier, but yeah. There we go. So there we go. Sorry about the lack of reading right there. I was a bit locked in, I think. So where is this? This is there's an identity here that I don't remember. I think it's, yeah, it's the determinant maybe. No. Determinant, inverse. No, it's not these either. Inverse of small matrices. No, that's the inverse. I think this is it actually. Is it this? What? No, I think it is actually. It's the last one. Or is it 1.8? I'm stupid. I think it's actually. I think if I just looked at the equations up here, then it would make a lot of sense. That was it. Yeah. Okay. So, yeah. That's what we're trying to do. Okay. So we have this not identity, but way of doing the calculation. All right. Fantastic. Okay. So it's just where A, B, and C are what matrices. Sorry, vectors. So upon closer look at the right side of the equation, we see that the upper matrix vector product MV is a linear combination of column. Okay, yes. Okay, so we just have a linear combination. Okay, so it's okay. Right. Okay. So if we have, just say so, if we have this. Assuming we take into account this. Oh, I'm going to have to write this out in LaTeX. MV V underscore X. Oops. Plus V underscore Y B. So I'm going to write these as vec A, right? Oh yeah, this B plus spaces out so it's a bit easy to read, and this C, where A, B, and C are all column vectors from matrix M, right? So that's the identity we're working with. Oh, my laptop's about to die. Do you write your own math library for matrix multiplication, or do you use a library like GML? I use a library like GML. But this is more for understanding rendering than it is. I went in the wrong book. Hang on. So like how to deal with. So let me. So this is like how do we derive the adjunct matrix to work out the normal matrix for working out normals, right? That is done in the shader. There's no GLM in here, right? So this, for example, right? Like I do the adjunct matrix, then I cast it to. Sorry, I turn this into an adjunct matrix, then I cast it to a vec3 multiplied by the normals, and then we get this. I want to understand this better, if that makes sense. So that's what we're doing right now. That's why we're doing this type of work. Oh yeah, Matt's got a really cool little self-improvement app, which we've talked about. Oh, so we've talked about personally. You know, it's always nice to see creative minds coming up with creative solutions for difficult problems. We can rewrite out. This. Sorry, yeah, I need to actually sorry, n to the power of b in b space is equal to ms x no / times. I think it is MT, right? Yes. As. So what I'm going to do here is I could. Let's write this out first. So n to the power b equals s x. I think we can copy and paste this quite quickly so we can get through it. M subscript 0 plus, yep, this is going to be trivial. Dude, plus this, and we have 2, 1, z, y, and then times. We just do this twice. And we do this now with t. So t, t, 2. There we go. Fantastic goal. How do you connect neurons? I assume you're talking to Matt. Sorry, mate. I was building and watching you as well. Yeah. Took time to reply. Oh yeah, Matt. Didn't see the Matt reply at the end. Yeah, it's a fun app. I wonder if I can use it and be a better programmer. Hopefully, you never know. Where we are using MJ for column matrices, yes. So M underscore J. Oops. Our column matrices. We can simplify things down by distributing the cross products to all those terms and simplifying we get, so this is the adjunct, I'm saying it wrong, it's not the adjunct matrix, it's the adjunct matrix. So this is the adjunct matrix, which is on the left hand side, multiplied by everything that we need. Okay, so this is going to be trivial to write as well. It's just a bunch of copy and pasting. So it might take a while, but n to the power of b equals. All right, so yeah, this is definitely not part of a S. Yeah, so yeah, this is very familiar to me. T, Z, and then it's just the reflection. So this is just ZT. And yep. And then this is just M1. Yes, this is going to be a. Yep, no, that was right. Adjunct matrix, adjunct matrix. Fantastic. Right, let's just take this, do this 3 times. And now we want to do X, yeah, ZX, ZX, XZ. Oops. And this is now 2, 0, yep. Now 0, 1. And we're good on the final one. Done. So it's just XY, XY, YZ, YX even. Okay, so this is the y-x, then we want to do 0, 1. The z components. That's for each component of n. Anyway, wow, I'm gonna have to but you are going to, oh yeah, talking about the inputs and stuff about LMs. Escape point, bruh, you already cracked developer making games from scratch, and I was just fine coding, lol. Well, you know, it depends on your goals, right? I mean, if you're just trying to get something working and you don't really care about the craft of programming, then, you know, what might make sense, you know? I've seen some people make some websites and stuff. Alright, see ya. But yeah, just to finish that off, you know, no, not everyone has to be a super cracked programmer. You know, there's a t-shirt out there that said, I code so you don't have to. It's a bit of a Reddit tier t-shirt, I have to admit, but anyway. So the cross products of ASX is clearly visible, but it's maybe a little less obvious that the cross product of the column matrix forms the row of the determinant of m to the power of which follows the equation, which concludes the normal vector calculated with. Okay, we're nearly there. This is the final piece of the puzzle. The cross product of let's see, so LaTeX n to the power of a equals s times t, which is visible, which makes up the which may be less obvious that the cross product of the matrix columns form the rows of the determinant which follows from the equation. Okay, so so I'm just gonna go to that one. 1.9. Oops, I've done that again. I apologize. Let's go to 1.9. Yes. Alright, so I'm probably just going to copy and paste that. Actually creates the determinate of determinant. I spelled the determinate. Determinate. Is that right? Yep. Okay. Determinates of m to the power of -1 if looks like they have the educate matrix. Yes, they did. I had to thank you for teaching me that, by the way. This is the thing, like, I forgot all the maths and like I didn't realize what I was like forgetting, so I had to go back and do this for reals, you know. If we follow the formula, that's the equation, to work out the inverse matrix. Do-do. -1. How you doing, Ratchet? Hopefully your coding's going well. If you've done any today, because I know you like to work alongside me. Hopefully you're absolutely crushing it, as you usually do. A, B, C, and then we have a left. Oh, this is... I've got to make a matrix here, so let's try again. Begin. Matrix. End. Matrix. Okay, let's see if this works. A... Oh. Oh, yes, let's not do it in the fraction. All popular resources. All popular resources also use inverse transpose for some reason. So it's not your fault. Yeah. Yeah, that's true. It's not anyone's fault, I guess. I was playing Zelda, lol. Joined in to check what you're doing. Oh, yeah, okay. It's funny you say that. We were actually watching a game design video on Zelda, which is kind of fun. So... Bride. Okay, how do I do one that's lower? Okay, so that's like right next to each other. Slash slash. Okay, right, fantastic. So B times, oops, B times C. Oh, S, let's write times in. Yeah, we don't always have to be super hardcore with our time. Sometimes it's good to actually play video games and actually enjoy what you're actually trying to make, eh? Who would have thought? No, it's I've been playing, like I said, I've been playing a lot of Crash Team Racing recently. I often do that off stream when I'm just chilling. I'm actually getting faster at the game. I very much enjoy myself. So can I put this in like this maybe? It's kind of hard to. So left, and then slash right, please work. No, space, not space. Maybe? No, okay. I'll just leave it. I swear it was like this though, wasn't it? That's what I thought it was. Well, whatever. Oh, it really hates that. I see. Okay, so maybe this is bad. Hang on. Bear with me just for a moment. Sorry, right. Or no. Okay. I'll just ignore it. Or final thing. I'm a bit of a persistent guy when I want to be. Hang on. This and maybe this. No, okay, it really is not working. I give up. That's good enough. I can always just put a simple brackets around this, right? Like that. It's not ideal, but that will at least indicate that it's something, right? Anyway, vectors and matrices, indeed. We are figuring out why the educate matrix is constructed in the way it is, which is really cool. Right there it is. Thank you for joining us, by the way. He was crashing in a Zelda game. I played Rumbo 3 and an hour. Finished the game. Oh, nice. Finished the game. Hell yeah, dude. Very cool. Yeah, we're watching a video, a game design video on Breath of the Wild and Tears of the Kingdom, and like how it's changed its formula since it was back in the day, which is kind of nice. which is basically the so oops, we can conclude that a normal vector calculated with a cross product, I'm going to write this out exactly because we're basically there, product is correctly transform according to, I've got to write out more maths formulas. Let's go. Okay, so we love studying. Let's go. Almost there. These blue boxes means that this is an important formula to remember. So debt which is basically what we just said before. To the power of -1. Which is... Alright, so take this. I'll just write this down here. Cool. Nice. Okay. So, because of that, we can, using... Here we go. Here's the big one. Go down. Thank you. Using the adjugates, not adjunct, adjugate, adjungate, which is of M. Fine, I'll do that. I'll grab that formula as well. Oops, I did it again. Right, so let's grab 100 and 1.7. 1.7. Oh. Right. Oh, these are little small matrices. I remember this now. The sign, yeah. Ah, no, it's not. It's the, I forgot what it's called. It's got a special name. It's that weird matrix, which is just plus, minus, plus, minus, plus, minus. Alright, I'm going to leave that out. Yeah, we're going to leave that out. Oh, I was wondering what that was then. I thought it was a bald person sneaking on my screen. Alright. Right. Written as n to the power of b equals n to the power of a, and then adj. Are these like functions I can like mess with? Do you think? No. Okay. I highly doubt that would be a thing. Yeah, it's not like cosine or sine, or, you know, something like that. Right. Okay, so I'm gonna write out. I'm not going to use their example because actually we have this code written here, wherever it's put. Yes, this thing. What? Go away. Oh, it's, I thought it said copy. Oh, I think you were playing a video game, right, Kalia? There's someone was crashing or something in your game. So with that, we can take in matrix. Yeah, we can just do this. Afterwards, let's put this in void main. Adjunct matrix. Adjunct matrix. I've spelled it wrong here. I missed an N. What did I? Let's look at my notes. Yeah, I did. Adjunct jung. Alright. Not a big deal, but... Whoops. No. Okay, there we go. This would look like this if we were to write it out in GLSO or something. All right. This is not only how normal vectors transform, but it's how any vectors resulting from a cross product between two ordinary vectors transform. Okay, so this isn't not only how normal vectors transform, but how any vectors resulting from a cross product transform between regular vectors. Let me fix the music as well after this song, I guess. Oh, I guess I won't be. I just cursed it immediately. Let's go with. Yeah, I'll go with this. I really like the song. Right. Okay, Dookie. Right, I think we've made a good amount of understanding progress, if that makes sense. Which is fantastic. Alright, so the equation 13 differs from 8 only by an additional factor of determinant n, showing that the two normal vectors are closely related, since normal vectors are almost always rescaled to unit length. After they've calculated in practice, the size of determinant is inconsequential and often ignored. Right, okay. Making the two normal vectors transform equations identical. Okay, so since we are dealing with normal vectors, like normal length, the size of the determinant is inconsequential and is often ignored. Oops. That's why. This is why this happens. We're only doing like half of the maths here. Okay, that makes sense. Well, instead of doing this, right, because this would be a. You can see we've done this here, right? We've done this. C. We've done BC. We've done CA, and we've done BX cross products, AB cross products. This would be like what? I'm gonna write this down, kind of like to help myself visualize. But because the determinant is so, because just we don't care about it, we just like kind of toss it, and that's why this works. Which is actually kind of clever. Whoever discovered that is actually really smart. Like straight up. I don't know where this has come from. This is some next level stuff, honestly. I'm always impressed by people who discover these things. Like understanding that the determinant is inconsequential, so this can be simplified to an educate matrix. Like what the hell? That's so next level, bro. That's so cool. And that's why we don't use the inverse, right? Because we don't actually care about the scale, because it doesn't scale the matrix. It doesn't scale the because that would technically scale normal vectors, but we don't care about it. Since the practice determinant is inconsequential and how often ignored, making yeah. Making the two I'm gonna grab this and let's get rid of that, hang on. And let's see. The inverse also has a problem. Not all matrices are invertible. Ah, yes, of course, of course. I'm gonna write that in my notes. Of course, you're completely spot on there. This is why I need to like know my maths better. That's like, yeah, that's really spot on. That's why it's incorrect. Oh, I wish Sad Vic was here. There you go. I forgot why it was incorrect, but now I know, because I showed some on that resource you shared, Ratchet. And I was like, why is it sometimes incorrect? Why is it sometimes incorrect? And I couldn't remember. Like inverting a matrix is basically the same. Also, not all right. I don't know if it's going to say this like later on in the book, but I'm going to write this down. Also, not all matrices can be inverted when the determinant of the matrix is 0, because you get a division by 0. Yes. Oh my goodness. It's like a blast from my past, like actually remembering all this stuff again. Of course. Because I studied this such a long time ago. That's why I forgot it's all. Well, not all of it, but you know what I mean. Whoa. I'm gonna open a window because it's getting really stuffy in here. So I'll just be right back as the ominous Sonic music plays. Bayek. Educate matrix. It's only half of the inverse. Very, very cool. This is faster, and it's correct too. So the inverse has, yes, not all matrix determine 0, which is IEEE infinite. Remember that 0, negative 0 is a thing. True. Mathematically speaking. And things in the adjugate matrix is cheaper to compute just through cross products, which are just multiples and adds 100%. Yeah, that's it's real sick, isn't it? Yeah, so this is all like coming back to me now. It feels weird, you know. I used to go to cafes and study this. On like a day off, I would just like sit there and do maths. With a cup of tea. It was chill. It was chill. Is inconsequential and often ignored, making the two. Oh yeah. However, the situation in which determinants have an impact. Here we go. Is in the case that transforms performed by M contain a reflection. When the vertices of a triangle are reflected in a mirror, their winding orientation is reversed, and this causes the normal vector calculation with the cross product of the triangle's edges to be reversed, to be in the reverse direction as well. This is exactly the effect that the negative determinant of M would have on a normal vector that is transformed by equation 313. Okay, I didn't know that. Okay, let's continue on. Okay, so I don't know if I should make a new thing here. Funny story. In one of my testing models, there was a mesh with a non-invertible transform matrix, which I only caught because validation complained about it while building an acceleration structure. Okay, yeah. Yeah, it's just like that could easily happen. Yeah, it could just like happen whenever, right? That is funny. So only caught it then. Right. Okay. So when you have a, let's scroll down a bit. Reflection. The negative determinant. Sorry, with one exception. When you do a reflection, the winding. Is this math for a physics engine? It's just graphics. This. But yes, this is just a. I'll show you what we've got going on at the moment. So I'm just doing a bit of maths for graphics, honestly. So this is my terrible. I keep forgetting this is here. UI, which I just got working like 2 days ago. But yes, it's this is where we're up to at least anyway. So yeah, we'll be we do have a physics engine where if you crash into stuff, it does get deleted. But that'll be for bullets, not the actual player. Yeah, so we're trying to make this like I'm trying to improve my competence so I can make this look nicer, right? And we do have a spotlight and directional light, as you can probably see when I get close without crashing into the model. And as obviously you can see, this gets brighter and brighter and brighter and highly contrasts the black background. So that's why I had a spotlight. Anyway, yeah, so not a physics engine. we are using someone else's physics engine. Why don't you try learning physics? I think it would help making a real-life similar game. Except in C and C++. I have made a physics engine in the past. I just don't want to make it again, you know. It was very complicated, and it was very... It took the numerical precision and understanding the theorems at the time were just very difficult to get right. So I'm going to leave it to, you know, what I'm going to call smarter people. For now, at least. If you are interested in my, like, you know, basic physics engine, it is on GitHub. I'll just show you that, I guess. Whoops. Come back. Where have you gone? So yeah, if you do want to check out my physics, my Impulse Baby's first physics engine, what am I doing? It's on my GitHub, which I'll just link because my main project is linked below. But if you do want to check out, if I type in wind, my wind project is a physics engine, and it's it could do the separating axis theorem on. To work out the separation velocity on convex geometry. It could do constraints. Some of my earliest videos are using constraints, but it was very difficult to use, honestly. So, just a bit of a law throwback to anyone who's like remotely interested in this kind of stuff. If I go to my videos, right, and go to my oldest, these are from that physics engine, right? But they are using it's called a master grade physics, but they're actually just doing the particles. This is like a throwback from 11 years ago. Yeah. And again, a lot of this was from a book. I wasn't like doing this from scratch. I was kind of like a noob at the time. But yeah, this was really hard to get working even then. This is all written in OpenGL. I believe this was written with Legacy GL, so this was not even, it didn't even have shaders. Yeah, this is like, and I obviously put that there so you could see it was 60 FPS. Back when screen recording software was annoying. Yeah. But yeah, yeah, I'm gonna leave physics to smarter people. I've been there, done that. Definitely not up for redoing it. Hello, I'm good, thank you. Thank you for joining us again. Hope you're having a great day, dude. Just showing everyone my old physics engine that I'm not continuing on with because it's a bit of an old, cranky, numerically imprecise physics engine. Anyway. I mean, it's fine. It's I like it, but it's not really that useful for anything else other than small demos. Yeah. Anyway, so one exception is that reflection. When you do, yeah. If I spent more time doing graphics instead of physics back in the day, I would be like graphically way better off, but I'm still grateful I did physics for a while. That was a couple of years of practice to get the separating axis theorem to run on convex geometry, for convex geometry, simulate particles, have constraints on those particles, and have constraints on 3D geometry, along with buoyancy and all regular forces like wind. But that's not hard to do. Like, forces just added together, so it's really simple. It was rendering the last time. What did I miss? Yeah, it's well, you haven't missed anything. That's just like my older projects. My older projects is a physics engine, not the current one we're working on. That would be the wind code. If you're interested, it's on my GitHub under the wind project. It's largely based on the Cyclone physics engine, but that's like built for a buck and that. Honestly, it was very difficult to get working. I only ever got the graphics working with OpenGL 2.1 when I was building that physics engine. But yeah, it's pretty tricky. Oh yeah, and I wrote all the maths and rotational physics myself, which is nuts. Trying to figure out how 6 degrees of freedom work when I didn't know or understand what a quaternion even was. Like, ugh, man. And writing that in C++ code, oh my goodness. Yeah, I don't want to do that again. I basically wrote GML from scratch and my physics engine from that onwards, and I made so many mathematical mistakes. I remember for a while I didn't catch that when I normalized a vector, it wasn't even correct. So like everything was broken for like months because I didn't realize I didn't code the normalization of vectors right. Oh yeah. Crispy, yeah. Hi Crispy, yeah. 5090 to the rescue. Maybe one day. Maybe one day. Might be the 6090 by the time I can afford that kind of thing. Anyway, with one exception, reflection over vertices. Yeah, I've many stories about that physics engine. It went on for ages. It was a great time. I'm pretty nostalgic about looking back and coding that thing. Although, oh my god, I made no progress. It was so slow. Oh my goodness, it took forever to do anything. But I didn't care. I did it anyway. Anyway, enough being nostalgic. Anyway, yeah, when you do, yeah, that's why I never did my own physics. Yes, just use Jolt. Yeah, back then it wasn't as obvious. Jolt didn't exist, and I was like, oh, okay, it's just gonna. I was so naive. I was like, oh, it's just gonna be dead easy, right? It's gonna be like it's gonna be like all I have to do is this, right? Dead easy. Oh my goodness, it was so difficult to get anything working. The wise choice is to definitely use a physics engine, like PhysX or Jolt. Yeah, we are spoiled nowadays. Holy moly! 11 years ago, I don't know what was available. I think PhysX probably was, but I still don't know. Anyway, with one exception, reflections, reflecting vertices, the winding gets reversed because when you do a cross product, the upside there is that physics engine got me my first job as a software engineer. For rand rot. They were only interested in rand rot. If you've never heard of it, it's a really fun algorithm for randomly an RNG. It's not used anymore. It's like obsolete due to the fact that it can't be vectorized, so you can't do SIMD operations on it because it spills over into different byte boundaries when you do a rotation. A binary rotation kind of thing. It's really cool. But yeah, they wanted me to know, like, they were like, how on earth did you code randrot? They didn't know what it was at the time, so I had to explain it to them in the interview. And I was like, oh my goodness, I coded that like 3 or 4 years ago. I had to like remember on the spot what it did. That was great. It was great. The whole thing's worth doing. Yeah, it's a fun project, but not something I want to do again. Anyway, because so the cross product between, yeah, look up randrot if you ever bored. It's like a really fun way of doing RNG. T and S. So, I've got to look at it again. Hopefully, you don't mind me being a bit procrastinated, being distracted. It's just beautiful. You got me started now. Right, where is it? I've got to. barely remember how this, like, what this structure of this code was. Graphics, probably not here. Where was Randrot? It was in the core code. Geometry, broad face, narrow face, contacts. No, where's the application? I think if you look in application, we'll see it being used. Oh, no, I went to 3.2 OpenGL. But there's me still using like some of the older stuff. There we go. I was still using like legacy OpenGL here because I didn't quite know how to do stuff. Like I was still using GL Vertex 3. But yeah, let's try and find a Randrot wherever it is. Spreadsheets, sprite sheets, no. Block. Where did I put it? Not fonts, not mesh. Object loader. Collision detection. It's got to be in core then, I think. Core was huge, or is huge. Okay, there's a bunch of vectors. So yeah, that's what I was talking about. I messed this up like 3 times. That's how you normalize a vector. Where's Randrot? Quaternions. Matrix 3. Matrix 4. That's vector. That's the Matrix 4x4, which was used in the yeah, perspective. Okay, it's not there. Yeah, bear with me, guys. It is actually quite fun to look at. It is like world, maybe. Like, I need to find the include where it lives. No, it's got to be pre-core because there's number. Is the RNG in here? No. Where on earth? You know what? It might be best to open my project right in my. Yeah, let's try and do that. Now, where is it? I think it's going to be here. Yeah, okay, so yeah, this is a project, but I think it's got it's not quite morning. I hope you're all good. Sorry, bear with me. I really want to find this because it is super fun. It is like super, like writing your own. It must be. Is it block? What I'm gonna try and do is RNG. Nope, that was my Windows noise. I don't think I have, unfortunately. Camera, game, main, timer. Yeah, I don't have code blocks installed at the moment, so I can't boot this up into a project. Well, I mean, what I could do. We'll get there. We'll get there. Components is not external. That was me trying to make a game out of it. Bear with me. Application now? Okay, what I'm going to do is just open these all up in... Yeah, let's just open these all up. Can I do that? Okay, it's just going to do this. Rand. Yeah, find all. Does that exist anywhere? Not find and replace, just find. Oh, RNG. No. Really? Okay. If only I had grep. Yeah, binary space partitioning. Let's try these. Oh, random. Find all. Starting a physics engine 1.2. Friend of mine got a job after engineering degree. Knows Python, but getting Java. Oh, interesting. Ah, that was it. I remember now. It was called random. It was literally called random. I just need to find the file called random. Yep. It's right there. Okay, so let's go back to our GitHub. Sorry about that, guys. It's taking so long. Yeah, found it. Of course, I just literally just got a flash. Where is it? Random. Where are you? Okay, so it's inside include. So I want to show you on GitHub because it's like got better syntax highlighting. Oh, look at this. Nope, that's links. Where? Okay, I forget. I don't know what that's doing, so I'm just gonna open up on this. Okay. So you have to rotate left and right based on bit shifting. And yeah, you set a random seed. I still use the clock. So if you set a seed to 0, then use the clock. Obviously this, okay, now this is because it's untimed. It's going to be huge. Okay, so some of this stuff I don't quite remember, but I remember having to explain like, okay, so when you do this like right rotation left and right based on the bit shift direction, you basically spill over into different boundaries and kind of mess things up. And you're able to take a buffer, which I believe is just the seeded value multiplied by a big massive number plus 1. It does have proper random characteristics, but yeah, so floats was a bit harder. You can see how it's spilling over into different boundaries, right? So we got like a bit shift of 20. So it's like you can't really vectorize this anymore because of that. Like the operations are kind of like awkward. But yeah, you would like allow things to kind of mess with each other, and you get like a random binomial, which would just be the same thing multiplied by a scale. So it was like a really this got me a job basically. This thing alone, I had to like explain this on the fly, and I completely. At the time, I was like panicking because I was like, "Oh no! What the heck was I doing?" But yeah, it's this algorithm is called Randrot if you actually want to look at it yourself. But yeah, it's not used anymore, like I said, because it doesn't scale, and I don't think it's obviously like people have got better at building random numbers now than back when this was written a long time ago. But yeah, it's pretty cool. I just like it. Yeah, the fact that you're spilling over into different boundaries, all to get a random bit, Anyway, hello guys. A lot of OpenGL you can grab. Yeah, that's true. We found it in the end there. Grep in bash. A lot of OpenGL resources are still very useful in any other API. It makes sense, yeah. Let's just catch up with chat. After looking at Randrot, classic blast from the past. So I got a little nostalgic, guys, for a physics engine that I wrote in like 2000. And I basically wrote it instead of doing my university work. I wrote this instead. I wrote a physics engine. So let's read this properly. Crispy has said, my friend got a job after an engineering degree. He knows Python, but getting Java training by a company role. Oh, congrats to your friend. So yeah, classic escape, but yeah, switching to assembly. You gotta switch for assembly. Anyway, let's close that. We had our fun. But yeah, like I said, that project's in Wind with classic OpenGL, legacy OpenGL, and legacy and OpenGL 2 and 3 all mixed in. With STL 1.2, I think. It still uses STL 1.2, I think. But yeah, Randrot class algorithm. Anyway, so those are the days. Yeah, I don't recommend doing that, guys. If you actually do want to learn physics, it's like a whole very specialized field. If you want to make a physics engine to make a game, which is what my goal was at the time, it's probably not the best idea. But then again, you know, people would say that about making your own game engine in general, so who am I to stop anyone doing anything? Anyway, so would be reversed by the determinate yeah, I've got more stories about that physics engine, but I'll leave that to another time. So educate matrix. I want the whole thing. Where's the whole thing? Because we're actually doing a multiplication by a vector here, and yeah, the hardest part of the physics engine, honestly, was the not that, but the broad narrow phase collision detection stuff. This was brutal. Get collision points, and then doing, yeah. It was just so difficult to get right, because you had to do like lots of checking if the part of a convex geometry was overlapping with another. It was very, very difficult to get right. And I didn't understand at the time that doing convex hulls was a bad idea, and I should have just stuck with the collision geometry. I just didn't understand so much what I was doing, honestly. Yeah, and you had to work out points that could be on edge, that could be on the face, and that could be on the corner, which is very difficult to get right. And my numerical precision wasn't perfect. I mean, it was okay, but it was like nowhere near like what Jolt level is doing. And even like for sphere versus sphere, yeah, sphere versus half space, this was the true test, because you had to work out the separating velocity. It was just I struggle. I remember struggling a lot with this at the time. This was like, yeah, painfully difficult to get right. But yeah, I have written a physics engine. That's one thing I can say. Yeah, this was the hardest collision detection, the box versus box, because it wasn't an ABB, it was an OBB, oriented bounded box. So yeah, it was a very lengthy process that I had to go through. And this was like after a lot of debugging, and I wasn't as good as a programmer as I was back then, that I am now. Anyway, yeah, physics equals more maths. You feel more pain in your body, not brain. Yeah, it's fun. It's just different types of application. It's not impossible, by the way. It's just like, if you want to make a physics engine to make a game, it's probably not the best idea. Anyway, official ramble over. And I'm still trash at programming. Oh well. Life goes on. Anyway. The code listing in 3.1 multiplies a normal vector stored a vec3d data, treated as a row vector by transform Okay, so this is talking about listing 1.0. Right, I wonder if it does anything different. So I believe what this is doing here is it's still doing the cross product thing. So we just got to be careful of reflected, right? When we reflect, we kind of lose its virtual physics anyway. Yeah. Definitely, yeah, it's just a very niche, like I said, it's a very niche thing to get into. It's, yeah. I don't think it's as popular as well with hiring for jobs if you're interested in getting a job. I think it's one of these fields, if you get in, you're in for life, just because not many people can do it, and there's not many jobs out there, so people don't there's not many people who can do it, so you don't get let go from those jobs that exist. But yeah, it's a tough one. I did apply once to be a Unity physics programmer back when they were hiring for that a long time ago. But yeah, I didn't get anywhere. Showing all the two types of normals are closely related, since the normal vectors are almost always rescaled to unit length. Okay, so we read that already, sorry. Okay, so the code listing there multiplies a vector. Okay, so this is just what we did. We've already written it there. Okay, so so be careful with reflecting vertices as it reverses the winding, right? I glazed a physics book. I did not understand. I understand nothing. Fair enough. Yeah, that's I don't want a job. I wouldn't want a job with programming. It would probably ruin the fun. There's something to say. There's truly something to be said about that. Yeah. I don't want any job. Yeah, I feel you on that one, do you? Who wants a job, really? We just want to be able to chill and do what we want in life. Anyway, the position normals are being transformed to 4x matrix H. Okay, so P is transformed by HP, sorry. But a normal has transformed by the inverse of M, where M is the upper 3x proportion of H, being able to multiply. Yeah, okay, so this is pretty much what we did by transform 4D. Data structure is convenient for both H and inverse H are already available. That matrix invert does not need to be extracted. In general, case H and M to the power of -1 to be transformed both positions. Just over broke, yeah. Are you removing jolts and using your hand-rolled physics engine now? No. It wouldn't be a good idea if I did that. I mean, it would work for what I wanted, but it would not be stable enough to do what I want eventually. Like, don't get me wrong. I think they're using a constraint based by default, but you know, my physics engine was an impulse based physics engine, but it wasn't very numerically stable. So you would get, like, if you stacked boxes on top of each other, they would like vibrate and like fall over, due to the fact that it was like impulse rather than constraint based, which is stabler but a lot harder to write, because it's not very generic. Well, that's what I got told in the physics engine book anyway. I could be completely wrong. Anyway, in general, both H and M are needed to transform both positions and normals. If M happens to be orthogonal, orthogonal. I want to say orthogonal. Orthogonal. There we go. I had to say it wrong to say it right, which is often the case. Then its inverse is simply equal to the transpose to the transform matrix is just n transpose m, but this is equivalent to m I see if we treat n as a column matrix. Thus, it is common to see game engines treat ordinary vectors and normal vectors as the same kind of mathematical element, use multiplications by the same matrix H on the left to transpose both kinds among different coordinate systems. Yeah, programming. What was it something to do with resolving collisions? Yeah, that's the hardest part. Oh, thank you for the donation. That's really kind of you. Just watching. I appreciate that a lot. It's always nice. Always nice to be appreciated on stream. Thank you very much. Yeah, shocked face indeed. We are not moving to a physics to a hand-rolled physics engine. Although that would be fun, but it would be, you know, the game would come out in 2060 or something like that. Yeah, so yeah, thank you for the lovely donation. It's very nice. Programming for fun is my main priority. Yeah, that's awesome. Yeah, 2060. Yeah, let's not delay the game to 2060. Yeah. Okay, yeah, that's fine. Let's. What I'm gonna do then is just kind of separate these off into their own. No, actually, just keep going. Just keep going. We're on a roll. We're on a roll. I forgot how much I enjoy streaming. I took a few days off because I was feeling a bit burnt out, but oh my goodness, it's so fun hanging out with you guys. It's honestly, yeah, it's real chill. Okay, so here's the 2077. Yeah, maybe GTA 7 will be out by the time I finish if I end up using my own physics engine. So lies and rays. This is the real meat of the thing that I really wanted to get into. But I'm glad I went over the normal matrix again because it was a nice revision of it was a nice revision of, what is it called? Matrices and how everything kind of works together. I'm questioning myself. Where is he? Yeah, I don't know. Oh yeah. Oh yeah, because I was off for so long. I see what you're saying. Yeah, I was thinking you're spending some time developing a roadmap. Yeah, maybe that. I don't know if I'll actually do that. That's the tricky part. Because it's like, I guess I think I said this enough, but it's like most of the time you just need to practice for like 5 years and then you'll know what you need to do. Which is kind of a cop-out answer to actually building stuff. Lines and rays. Yeah, who released first, a skate point or a rock star? I love that. All right, so let's dive into this awesome chapter. Parametric lines and all that kind of stuff, because I really need to remember how they define. What I'm really interested in is how do they define planes. Planes is kind of the tricky part, because they define planes in a very strange way. So let's say the geometry of lines. Again, this book's in the description if you want to copy yourself a copy. It's quite good. Now, I have read this before. I just haven't retained it much over the years. Alrighty. Okay, lines and rays show up in numerous places throughout the game development. Oh yeah, rays. Yeah, I think it's lines first, so I'm just going to stick with lines and then kind of go with rays. Let's just see how to split this up. You know, I'll just split it up by subchapter. Yeah. Anyway, Numerous places throughout the game engine development are used for many purposes that include rendering, collision detection, and user interaction. Lines and rays are basically the same thing mathematically, with the only distinction being that lines extend infinitely in both directions, while while rays start at a point and go off infinitely in one direction. This section introduces parametric form of a line and discusses some of the calculations that can be done with it. Later in this chapter, we will encounter a different mathematical formulation for lines, and that will also appear in a different context in 4.2. The first Mika already, is at 17%. Yeah, he's been checking out his streams every now and again. Yeah, I'm enjoying them as well. They're all sick. It's great to have this like group of guys like that that are, doing great stuff when it comes to the game development stuff. So parametric lines. Parametric lines aren't that complicated, but they're kind of awkward to use. In my head, anyway, I struggle with them a little bit, so this will be nice. Given 2 points, P1 and P2. Sorry, my voice has gone a bit crunchy. I'm just going to hit my mic, so I'm going to mute myself briefly. Okay, yep, okay, that's good. I think I've got a loose connection inside the microphone. Okay, so given 2 points, P1 and P2, we can define the function L, this thing. Okay, so I guess I'll write that down. Given 2 points, points P_1 and P_2. You get this function. So that is, I don't think I can get away with that L, so I'm just going to do capital L. Alright, so that's, and then P, which we've all seen this before, hopefully. Well, if you haven't, here we go. Yeah, parametric lines are kind of like defined over the domain of 0 to infinite if it's thingamajiggy, right? I discovered that I know a lot of maths that went unused throughout my life until now. Yo, here we go. Yeah, it's like you're probably familiar with this. This isn't as complicated as what we just did, but it will creep up there. It's going to assume some identity knowledge when it comes to projection of vectors, which I think that's what's happening here. Yes, that's a projection of a vector, right? It's kind of tricky. But if you got vector projection, then you can be able to find the distance between a point and a line based on a vector projection up to that point, and you project that onto a line. It's kind of tricky though, so yeah, I don't know if I should. I think I'm just going to read this rather than write so many notes, because I think at this point I kind of know what I'm doing with points, with lines at least, despite them being a bit awkward. So we can, for rays, this would be defined over the domain 0 to Oh yeah, / infinity. Is that right? I think it's like 3 letters actually. No? I was writing this down in the Monte Carlo stuff all the time, so no, it's best to look in the probability review because I wrote that down all the time. So I'm going to change the music in a minute just because it's I think it's repeating again. Where is the domain? Where's the infinity? Can you search by infinity actually? Okay, I'm just gonna look it up online. It's gonna be faster. Okay, LaTeX infinity symbol. How do I do that? Yes, how do I? No, this is useless. This is not good. Okay, that's it. Yeah, it's a strange symbol. So if we go back to this, and I need to do a so not include infinity obviously because that would be insane. Let's just change the music real quick. Yeah, so it's repeating music I think. Yeah, okay, we've had that a lot. Let's go. Oh, I won't. Let's play one of my favorite tracks. If I have access to it. Where's it gone? It's around here somewhere. Bear with me just a little longer. I should find it. Okay, so it's not. Oh no, we're not at the bottom. Are we? Yeah, okay. That wasn't it. It's just it only loads 200 tracks at a time in YouTube. Okay, there we go. This is such a good track. Alright. We can easily rewrite this into this formula. I've just never. This is just lerp. This is like a very basic version of lerp. I think lerp is the beginning of this, maybe? I don't know. Because this is a lerp. Linear interpolation, right? Where we just use a ray over a certain distance. Where... Hang on. Yeah, sorry. Where V is just... Yeah, I was going to say... yep, that's fine. P2 minus P1. Yeah, self-loading is super fun, 100%. I recently feel like not under pressure, but yeah, there's so many things I need to know. I just thought today I'm just going to study maths and not even think about it. So I think recently I've been stalling out just because you know, not doing much studying / work, because I've recently acquired 2 extra books for graphics programming, and I'm just like a bit overwhelmed with how much I don't know and how much I need to study. But at the end of the day, this is just like the actual act of learning is fun. Worrying about learning is not fun, you know. I don't recommend doing that. Just pick something and go nuts. Is my advice to myself and other people. You know, doesn't matter if someone comes out of the woodwork and calls you a hack loser or something, just because you don't know some random thing that they decide was important. you can just pick anything and then, you know, enjoy yourself. Yeah. Anyway, so figure 3.2. The only difference between a line and array is that t can be any value where, yeah, t can't be negative. So, it's often the case that v is normalized to a unit length. So the parameter t corresponds to the actual distance of the starting point of b. Yeah. So it's often, I'm gonna have to delete that. It's often the case that what am I trying to say here? V is normalized. Excuse me. Is a normalized vector. So t corresponds to the length of v. Fantastic. Look at that. Hell yeah. Right, let's go. The parametric lines, yep. Let's see, let's grab this and not including infinity, negative. Infinity. Alright. Alright, cool. The moment when Alan Turing solves the enigma in the movie, that is what kind of feeling I seek. I know exactly what you're talking about. Yeah, that's a sick moment. All right, cool. Distance between a point. Oh, excuse me. And a line. I don't know why I'm yawning so much. It needs to go to bed earlier, obviously. Dun, dun, dun. Yeah, there's nothing better than that. That, like I said, that one of the I won't go into the details because I've talked enough about my physics engine, but that I had that moment when I was working on my physics engine. I rediscovered some things that existed already, but I had to like solve them for myself using maths, and then I coded it and it worked. It was great. Suppose that we want to find the shortest distance d between a point q on a given line of on any line he turned down Keira Knightley. Anyway, just like real life. Yeah, I think that film came out in 2018. It feels like it came out ages ago now. Yeah, it's one of the better biopics that exists out there. By one of the computer goats of all time. Yeah, it'd be very, very hard to pick, you know, more impactful people than Alan Turing. When it comes to computers, like John von Neumann, maybe you could say. Yeah, because the amount of progress he advanced computers in that was in the early days was huge. And obviously you've got like the people who came after that, like Dennis Richmond, I think, and the guy, what's his name? There's loads. There's like a whole lineage, but yeah, if you go all the way back, you end up with like Alan Turing and that, and the original mathematicians when it was just a subfield of mathematics. Anyway, suppose that you want to find the shortest distance between distance D between Q and any point. Oh, excuse me. On it. Okay, so that's what we're trying to do. So if you want to find a point, find the lowest, smallest, there we go, smallest distance D with a given point. I don't like using Q for points because it just reminds me of quaternion too much, so I'm going to pick given point. I'm going to say A using the formula equation function. There we go. For convenience, we define U equals Q minus P, as shown in figure 3.6. D is equal to the magnitude of the rejection of U and V, which corresponds to the right hand side, the right triangle having a hypotenuse of unit of length U. The length of the remaining side is the magnitude of the projection of U onto V, so we can be expressed with D squared. Okay. Right, this is kind of tricky because there's the line, there's Q, there's a normal vector. Rejection and projection are both two different things, and I've forgotten what rejection is. That's why I said, oh no. I was like, oh, what's rejection again? I'm just so attractive. I've never experienced it in my life, so I just don't know what it means. As shown in figure 3. Okay, so I'm just going to look up rejection real quick. So what I'm going to do is just open this up twice. Just so I can look up rejection, which is where's rejection? I'm gonna look for it. Completely forgot what this means. Because it's something to do with projection. It's like the inverse of projection, and I've completely forgotten. Yeah, okay, so we're gonna have to remember what projection is. Yeah, vector projection and rejection kind of come hand in hand. They make up this thing, which is basically how you work out the distance. So if you understand vector projection and rejection, then you're chilling. The problem is I don't remember. Alright. Who knew graphics was so mathy, eh? Got scammed here. Okay, so I think I'm just trying to figure out how I'm going to study this. Do I want to take notes on literally everything, or because that's the projection formula, and the rejection formula is the one that's perpendicular, I think. So that's the projection matrix DB. No, I can't remember which one's which. Okay, so projection is this. Okay, that was right. Onto A, onto B, which is taking A and sticking it on B, and the rejection of A from B. Okay, so that's this thing. Yeah, so it's just a rejection calculation. Right. Are you writing C code? I only write C code in my notes for GLSL because there's no GLSL extension. If I do this, there's no shader support, so I have to write. And C++ is kind of like, it's basically the same, but I don't want it to be kind of weird because the GLSL is closer to C than it is C++, so I kind of put it as he's like me for real. Yeah, TT and I understand the burden of being a Giga Chad. Of never understanding rejection. Alright, okay. Alright. Okay, so what I'm gonna do is I use C++. Yes, C is awesome, C++ is awesome. It's just for no it doesn't really matter. Like I said, it's just GLSL is closer to C. So that's the only reason. Okay, so I think we're gonna have to do a quick recap on vector projection, so yeah, that's chill. There's no reason. Okay, so I'm just gonna have to do a quick vector projection to completely, because this is important for like weird stuff. All right. Is the heat wave also in the UK? It's just passed. It is currently regular temperatures again, thank goodness. But yes, we had it for a week. We're stifling in the heat. So if it's moved on to you guys, my empathy is with you, because holy moly. It is Bayed. Hi, how you doing, dude? Good to see you, my man. Hopefully no one else is experiencing the heat wave in the chat. Anyway, so let's is that you, Space Game Bro? It is indeed. Yes, congratulations. I'll show you where we're up to, I guess. We have a really basic main menu. Woohoo! 2D renderer. We built a 2D renderer for this. And yes, we're using a sprite sheet renderer to do 2D. And obviously we have click a button that starts. And yes, this is where we're up to. You've probably seen this then. We have ducks still flying around. We could crash into them, but they're kind of hard to hit. Classic. Oh, it's same UI. Okay, yeah, you're familiar. Nothing's changed then. It's sometimes hard to keep track of people, so. But good to see you, my man. Good to see you back, my man. Currently studying mathematics. We learned earlier. He reached 35 in winter here. Ugh, no. Ugh, I hate it. 35 degrees is... Ugh, I can't even handle 35 degrees. It does get down to freezing where I live, though, so that kind of sucks. Like, we had negative... was it 5-6 degrees for like a couple of nights, and that was cold. We don't get the coldest temperature because I live near the coast, so we don't really get snow. But at the same time, we don't get the hottest temperature, so I'm very grateful for that. Anyway, we learned earlier in this chapter that vectors can be added together to form new vectors. But situations arise which we need to perform the opposite task. Given a particular vector, we might want to find 2 or more vectors that specify with a specific alignment that add up to the original vector. With specific alignments add up to the original vector. This process is called decomposing a vector into a separate component. Okay, so sometimes we need to be able to work out how much, work out the 2 vectors that make up one vector by decomposing them into separate components. Can I just get the length of these? The most straightforward decomposing involves breaking, a vector into pieces and aligning them on the coordinate axis. Yep. I, j, and k are commonly represented for the unit vectors in the positive x, y, and z axes. And they are defined as I, j, okay. Cool. Commonly, we would want to do this by using okay, so the easiest way, I'm gonna say the easiest. I don't need to write this down, this is like too easy, right? I'm just gonna write this down as you can just get the lengths of the x, y, and z axes to get the individual matrix vectors components are vectors. Okay, so bro, I'm interested in learning how people make mods for games. Is that a single tool? Is that a single tool all along, or each games have community built tools and present there? I think it very much depends on the game itself, and what are the things needed to build a game. Oh, okay, that's just like a bit more of a general question. I can tell you more about that, but yeah, mods are kind of like tricky, because it's like dependent on the game itself. So yeah, if you want to build a game, you first want to build want to learn about programming language. Yes. In game dev, you might want to create game via yes. Yeah, 100%. That's Daniel is yeah. If you're absolutely brand new, is it really hard to learn game development and mods? Or right, okay, so it depends on what you want to do. So I'll say there's 2 paths, and I think Daniel has talked about one right there. One path is using a game engine. The other path is not using a game engine. Depending on which one you pick, depends on what you should do. They're very different paths, and one will take much longer than the other to make games. Typically, the smart approach, if you're just interested in making a game, and you don't want to do a lot of programming, that's going to take you years to get good at, then picking a game engine is probably the best approach. Getting half decent at design, so you don't have to write a lot of stuff. You can make your game pretty interesting with limited amount of with lots of constraints, and then trying to make something that people want to play based on that. So yeah, it really depends on what you want to do, and it really depends on how you want to approach making games. What we're doing here is making a game engine, so that means that we have to do a lot more work, right? And that requires a lot more effort and skill eventually in programming, right? I think in my opinion, using a game engine and making a game engine kind of converge at the same level of difficulty after a certain point of complexity as games get better, right? So I'm not going to say that using a game engine is inferior to making your own game engine. I think they get just as difficult when you're approaching a certain level of complexity. A game needs a programming language to execute and run, like Minecraft and Java. Yeah, that's basically the beginning. So other games also need to work as the right ones. So yeah, that's the last I'm going to say on that. Okay, so I'm just going to read through this real quick. If you want to decompose a 3D vector, you do this with the coordinate system by simply picking out the components by multiplying the unit vectors and corresponding axes. We'd like to develop something more general than this, however, so you find a way to write the same thing without referring to the actual XYZ coordinates of V. The way to approach this is to realize that each coordinate is equal to the magnitude of V multiplied by the cosine of the angle V makes the corresponding axis. Okay, yes, so this means that yes, dot 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 equals the magnitude in different directions, which is completely chill. This illustrates the dimensions in this is illustrated in 2 dimensions. Figure 1.12 composed of equation 1.68 is called a projection of V onto. Sorry, it's called projecting V onto the vectors I, j, k. Okay, so figure 12 is vector V is projected onto I, j, and it's parallel to the x-axis. The components. Okay, so it's important to note that if the basics, so projection gets easier for the general case. If you have have unit vectors, basis vectors for a space I, j, and k. Oops, didn't put that in thingies. I, j, k. Now, the weirdest explanation for change of basis I've ever heard. Yeah. Projection is a dot product. Is it? Is that all it is? Oh. Yeah, thanks, guys. No problem. Good luck on your journey, dude. Yeah, thanks for helping out people in the chat, guys. That's it's always appreciated. Helps me get on with what I want to do when it comes to reading books and stuff. Thumbs up for you. Yeah, good luck to everyone who's trying to develop stuff. So, we take the dot product of okay. Yeah, I'm going through this so I can understand rejection more than projection. So I just want to get the things down of... Yeah, thanks for the help as well with the maths. I will C.I. I will incorporate what you guys have just said. Vec. And then .I. Oh, what am I doing? These need to be inside. Okay, and that should be good. Cool. And the same for J and K. Okay. Okay, cool. We should play games as a community. Yeah, I think we should do something together at some point. It's a bit more chill. Do something in the Discord or something. Get a multiplayer game going soon. Yes, mind games, yeah. Okay, so the general, in general, we can use the dot product to project any vector onto any other vector, any other non-zero vector b by using this formula. Okay, what's b squared? Is that just the distance? I see, so if it's normalized, this is the case for when things are normalized. However, to project properly, we can just use the general equation as a... Oh, I have no idea how to write that in latex, so I'm just going to put B. Actually, maybe just double bar will do. Oh, there we go. Easy. Easy. Okay, so fracking hell. C dot. I just realized C dot's a Pokemon. Keep saying it without realizing. Right, okay, so fantastic. Okay, so that's projection. And I think that's what it means, right? If the component... Okay, so A project B indicates that the component of the vector A is parallel to the vector B. Gives us A projected onto B. So yes, we are here. We are projecting a vector from A... Sorry. From A onto... Alright, cool. On to B. Fantastic. Cool. A onto B. The alternative notation is proj A, sometimes used in other texts for projection on A onto B. Okay, so, but every time I open my PC or laptop, I go straight to development. Yo, that's Sigma Grind said that. Hell yeah, bro. Yeah, I know what you mean. I only play when I'm like really tired at the end of the day. But yeah, we should do something fun at some point. Even if it's flash games for half an hour. Here the words component means part of the decomposition of vector A without referring to a particular coordinate. Okay, the division of B to account for the possibility that B is not a unit vector. Yes, okay, so we are dividing. Okay, this is really easy. Okay, fantastic. By B squared, because oh, hang on, I haven't distinguished these apart, so I just need to make these vex. Okay, I was trying to be lazy here and getting away with it, but I can't, obviously, because B squared and B look exactly the same, so that'd be confusing for later on. Which is easily fixed, but a bit of a faff. Okay, so there we go. Because B may not be a normal vector. I love that song. I'm tempted to download Unreal Engine 6 and start versing. I'm not sure what that means. But yeah. I assume that's some kind of fun activity. Anyway, so here the word component means that decompose means part of the decomposed projection of the vector A with referring to any particular coordinates. The division by B, yeah, okay, that's going to be unit vector. We divide by magnitude of B once the dot product, once for the dot product, and again, so the projection point, so that the projection points in the direction of the unit vector B over, yeah, B over length of B. Note that if the dot product B dot A dot B is negative, B project B A, then B, then, oh my god, I get my A's and B's mixed up. So A dot B is negative, then A project B is still parallel to B, just points in the opposite direction. No, if the dot product is negative, okay, so I don't quite understand what we're doing here. Okay, so the product B transpose B yields a symmetric matrix that can be multiplied by a vector A to perform a projection in 3 dimensions. We have this. Okay. Okay, so multiplied by the unit vector. We divide by the magnitude. Okay. And we also divide by the magnitude magnitude. We divide by the magnitude. I'm confused here. How does that make sure it's not negative? Just a real quick check something. Okay. Sorry. Back. Okay, so let's see. Let's read this again one more time. The division by b squared accounts for the possibility that b is not a unit vector. We divide by the magnitude of b. Is that the magnitude of b? B squared? Ah, okay, so that's what b is. Okay, so remember that b is the magnitude, I think. Okay, so let me rewrite this a bit. As far as right, I'm just gonna look up the projection matrix. Sorry, vector projection in a different book because I'm kind of confused what b in this case is supposed to be, right? So vector projection. Okay, so that's for a normalized matrix. Sorry, vector. Yeah, where's this formula? This is the generic one. I'm a bit lost here. Okay, so scalar project. Where's this? Okay, so this is that, I think. Okay, so yeah, this is definitely the magnitude. Yeah, so as far as I can tell, yeah. Double bars means magnitude often. Yeah, okay, so what I'm going to do then is kind of do this so to remove some confusion from my own brain. Now, unless anyone has a objection to that the dot product is divided by the magnitude. Oh, it may not be a normal vector. Also, we are dividing to correct the direction that the vector may be in. If the dot product is negative, then it's... No, wait. It's not correcting anything. It's just... I'm going to get rid of this, because if we project a vector that so happens to have an angle that's greater than 90 degrees, then the projection is going to be negative. It's just going to be the other way around. Yeah, like this. That's exactly it, yeah. This is exactly what I'm talking about. It's just going to be facing the other way, yeah, so... Meaning that the dot product is more than... Meaning that the cosine... Yeah, okay, so I was just going a bit nuts then. Of the dot product meaning that the angle theta between vec A and let's grab this. Oops. And oh, got it too much there. Alright, so B is greater, oops, what am I saying? Greater than 100, sorry, Jesus, 90 degrees, then it will project Negative. Fantastic. Okay. All right. Let's. For some reason, the music stopped again. Let's see here. No. Yes, we are still going. Fantastic. Okay. This. Hate it when it pauses right. You know, the YouTube says, "Oh, you're still listening," right at the end of a song. Anyway, just make sure it's still going. Cool. We've got Boss 2 from Thunder Force 4. Okay, right. Suppose that... Okay, we've done that. That's not what we were on. We were on very simple projection matrix stuff, which was here. Okay, fantastic. Now we can work on rejection, I think, because... So A projects onto B expressed by this. Okay, so I am super tempted to skip this because I'm just going to read this out, I think, because it's just another way of expressing it. Okay, so the projection of A onto B is expressed as a matrix product, which is like 1 over B, B transpose A. Okay, so the product B transpose A yields a symmetric matrix that can yield that can be multiplied by vector A to perform the projection in 3 dimensions. We have this. Yes, so is that skewed symmetrics or just symmetric? Anyway, the matrix in this equation is an example of an outer product. In general, the outer product between 2 vectors, u and v, is written as that thing, circle x, I guess. I'm going to just say outer product. Written as u, outer product v, is produces a matrix for the ij entry is equal to uv as shown here. Okay, so fantastic. I'm just going to say that's cool. Outer products is a thing. I'm not too interested, but I want to know this. This is specifically what I'm after. If we subtract, so vector projection, vector rejection, vector rejection. Finally, I'll know how it feels to be rejected. If we subtract vector projection from the original vector A, then we get the part. Oh my god, is that how simple it is? Then we get the part of the perpendicular to point to vector B. We've removed everything that is parallel to B. The perpendicular part decomposition is called rejection of A from B and is written with a projection minus. Okay, cool. Right, so vector rejection is just vector projection. I thought this was going to be like this drawn out, like super difficult maths thing. Oh, I've got to study a lot to get to understand what vector projection is. No, but it's it's just vector projection minus whatever you projected from onto. Anyway, minus the original matrix. Vector you projected onto. Projected from, actually. So if I took vec A and projected onto backslash project, vec b, we can find the vector project rejection. By simply by this. So yeah, right, let's write this out. That is, I don't remember. I do have that written down somewhere, so see if I can find it real quick in LaTeX. So if I look at my notes once more, we have, what do we have here? We have the Monte Carlo stuff. Where did I put this? It was... So I'm looking for a particular symbol that I used. Actually, I think it might be earlier on. Stochastic progressive photonic mapping. No. No. Oh, that's already thing clicked on. Alright, stop being lazy. Actually think about what you're clicking on. No. Biased. Accumulators. Okay, I think it actually might be the when we're talking about stratification of sampling. Where did I put this thing? Alright, I'm just going to have to... Because it's hard to... I don't know what it's called. Okay, we've already been here, sorry. So just bear with me just a bit longer. Important sampling. Nope. I think we've already been here. Sampling. Nope. Nope. I don't know how to write this thing. Biased. No. It's not balanced heuristics. No. Oh my goodness. Am I seriously not going to find it? So I'm just looking at my formulas. Or slash equations. Slash functions. I should. They're really functions. I really shouldn't call them anything other than functions. Oh, I'm dumb. It's directional. It's one of the. There it is. Yeah. It's. I just realized. It's called bot. Okay. Cool. Let's go back. Fantastic. Okay. So if I take and then put that in there as well. Yes, fantastic. And this is a vec. Put that in a vector. Fantastic. Okay, so equals a minus, very simple, a, these are all vectors again. This has got to be like my favorite Spyro track. So good. Alright, underscore b, let's do double bar for project, equals, and a very simple vec a minus this fella, which I'm just going to steal, because, yeah, we don't need to retype out everything. And except this is a okay, why have we got that twice? Interesting. Yeah, that's what I need. Okay, yeah, oh, that's why. Right, so we could go through the trig. Should we go through the trig? Because I've got enough. I'm gonna say, yes, there's a bit more going on here than just what we just typed out, but that's going to be enough to figure out to learn the distance. Right, so I'm going to steal that picture because I don't know any other way to grab it. Get that. Fantastic. All right, so throw this in there. Yes, this is vector rejection sound. That is good. Okay, cool. Let's get some water. Actually, this picture explains vector rejection and projection being part of a right angle triangle. Yeah, this is only true, I think, if... I don't know what would happen if it was negative. I think we would still get this, but it would just be the other way around, right? It would just be... Sorry, if this angle was greater than 90 degrees, so it would be a negative, so the projection would be over here. This vector would be this direction. Then yeah, it's just going to be that way around. So anyway, very cool, very cool. All right, fantastic. Now, because we've done that enough, we can go back to this and say, okay, yeah. So as you can see, this is very much a vector projection. Okay, so I'll leave the cosine and sine out. I don't know if I'm going to use them for now. Suppose that we want to find the shortest distance d between point Q. Okay, so what have I written? If you want to find the smallest distance between distance d for a given point A, using L equals L in T equals P, which is point TV function. For convenience, we define. Oh, I see. So we make another point. It'll make things easier. We define. Oops, another vector. So I'm going to use A here. Maybe I should make this capital just so it's easier. Yeah. Just so it doesn't say A point, you know. Makes things easier if we have another vector, which is calculated with... Alright, vec u equals vec u equals q a minus p, where p is the starting point of the line. Cool. So the origin point, really, not starting point, because, you know, in a line we're going infinite in both directions, so there's no real starting point. It's not like an array. It's not like an array, which, you know, is chill parametric, because we do have an actual starting point. D is equal to the magnitude of rejection of u from V, which shows... Okay, so the magnitude, so is equal to... Okay, so the D is equal to the magnitude of the rejection. Oops, rejection of vec u on to... That's actually really smart, whoever figured this out. Vec V, which corresponds to one side of the right-hand triangle, which corresponds... I love this song as well. Whoever made this playlist was pretty smart and pretty cool, and a pretty cool guy. I wish I knew him in real life. So stupid. I keep saying, "Oh, I love this song." It's like, who made the playlist? You know what I mean? It's like I didn't. It's like I put all my favorite video game music in a playlist, and but this is peak though. This is like peak Jack 3 in my opinion. It's like the best track in the game. Anyway, which corresponds to the line. Alright. Right, I'm just going to write this equation out now, which is going to be pretty tricky, but it's going to be fine. Right, so now we are, I guess, giga incels, because we now know what rejection feels like. Ah! I don't know what I'm saying. So we reject you onto V. Okay. So it's just negative U. What does this look like there? That's what I want to know. Right, okay, so there's some parallel pipette, no, parallelogram. Don't I make it complicated, making it 3D. Going on here. So the actual distance is this, so we have U, minus left, minus a dash right. Cool, and we're gonna write in frac U C dot V. These are all vectors again. Oh, come on. What's the V button? We know what that is. Alright. Backslash vec. Okay, so fantastic. Put this in here, like this, and V to the power of 2, which is the magnitude, I believe. Yes, we've done this earlier. We should know what we're doing. And all this to the power of 2. I hope I can just throw this in here. Oh yes, fantastic. Simplifying. So I'll write this out quick. The terms corresponds to taking the square root. Square root. Okay. Write this out real quick. So this is very nice. So we have the distance between a point and a line is equal to backslash squirtle. U. Okay, so this is just this, right? I'm just going to copy this last bit out, which is this fella. Fantastic. Okay, and done. Cool. I think that's everything that we need to worry about. Yes. Okay. Right. I'm going to share my Discord server with you guys real quick. Feel free to join if you're not already with us. Anyone's allowed at any skill level, as long as you have fun with us, and Follow the rules, generally speaking. Don't spam and stuff. The usual, nothing crazy. Yeah, so that is where I'm going to leave it, guys. Thank you for everyone who's watched. I very much appreciate you all commenting and asking great questions today. It's been honestly a really blast. I've really had a great time with you guys. Appreciate you all hanging out with me. Anyone who is newly subscribed, welcome. I hope you enjoy this time. Hope you enjoy future times here. And anyone who stays subscribed, you know, cheers for that. Cheers for that. You're the best. So, yeah, I will leave you guys here. I hope you all have a fantastic day, whatever you end up getting up to. And yeah, take care and keep crushing it out there, everyone. All right then. Bye, guys. No, that's quite fitting as the victory tune plays. All right. Yes. Bye, guys.